to work with her. And later, almost 7 years, I entered this historical building again in London. I was entering every day from the girls' entrance and exiting from the boys' entrance. It was very important years in my career because here with Zaha Hadid Architects, I had chance to work on international projects all over the world to get know-how with very special buildings, design methods, methodologies, and also with a lot of engineers. In 2013, I decided to move to Istanbul and open my own practice. It was very of course, not easy decision. And since almost 6 years in Istanbul, we enter from this door and our office is here. And it has been a new journey in my career. And at Melike Altinisik Architects, we are working on different scale of projects, and one of them is the tallest tower in Istanbul. It's the Istanbul TV and Radio Tower project. Today I will mention to you about this project as well. It's currently under construction. We do also another project in Seoul. It's a robot science museum project. It's a competition-winning project. We also work on cultural centers, office buildings, some high skill related social centers. There are very diverse variety of typologies we work on. And not only in Turkey, also on different parts of the world. We also do research projects. And today's main topic will be in depth the dialogue in between architecture and innovation. Before I start talking about the details of our projects, I would like to mention actually about the design understanding we have behind all these complex projects. This diagram is very important in our view because we believe that future doesn't have only black and white, yes or no. It has all the grays in it, and for the complex problems of tomorrow, we need to really understand these situations, and we need to develop systems which are capable of designing and constructing all these gray parts in our future. And for this, there are very important two things, and one of them is we need to learn how to look at nature. And when we say nature, we don't say that look at the nature because it's beautiful, because there are interesting shapes. Actually, what we want to say is when you look at nature, nature is always new. We need to really understand the systems behind the nature itself. When we look at this horizontal section of a wood, actually you see maybe a very nice circular pattern, but actually the scientists and researchers can read from this section a lot of information they can extract. And we can also, as architects, we can really zoom into details in nature to understand actually what makes these things happen. Here you can read the age, you can read the data related to the weather conditions, even like hundreds of years ago, where this tree was planted. And second thing is, for us, we need to know how to talk with technology. Technology is one of the important tools all the humans had actually since thousands of years. And if we look at in the last 100 years, actually after the many world wars that the world was going through, with the Industrial Revolution, there have been a lot of mass constructions were happening all over the world. And actually all these industrial revolutions, they let us to produce really, in a way, good resources to live in today. But future is different. we believe that we are living right now in this transition period where this mass production will turn into mass customization. It already started with the digital revolution, and especially since beginning of 21st century, all these internet and network connections all over the world started giving all of us the opportunity to really not only be part of the mass production, also we can customize things, we can personalize things, and we can also do this for our buildings and for the spaces we live in. And for this, technology will help us as a tool. Here, I would like to talk about, like 300 years ago, like people were working on the farms and the farm owners were actually ruling the world. 200 years ago, factories built, and so factory owners became really important people in the world. And actually almost 50 years ago, all the automotive sector starts having these robotic systems. And today, the data is really important, and the data owners all around the world became very important role. And the future in the cities, actually smart cities will be important for all of us. And in this next 100 years, smart cities will require smart design and smart construction methodologies. We are all using, as architects and engineers, a lot of us using the Autodesk products, because this digital revolution required also digital software for us to be able to communicate between each other, to collaborate between each other with engineers, with architects, with designers, and with city planners, all of us together. So these tools are very important to be able to express our design methodologies. And at the same time, as architects, we are using, actually borrowing some softwares from the other sectors, like from the aircraft, from the automobiles, from the animation sectors. And these industrial tools became also available today in our offices. We can use 3D printing in our office, VR, AR tools in our architectural offices. Even the robotic arms are becoming available for us to use in our offices.
И мы также используем обеспечение для того, чтобы реализовывать наши проекты.
And as a summary, you can see that the other sectors, as an example, the aircraft sector or the automotive sector, since more than 50 years, they have been using like robotic
технику, в производстве, инструменты в производстве, на производственных линейках. Это не что-то новое, но для архитектуры и строительства это новые вещи, потому что они не использовались ранее. И мы постепенно узнаем их, мы знакомимся с ними, как мы можем их использовать в нашем процессе строительства и проектирования. И мы также получаем...
Like from the
например,
sector, we are using
что касается авиации, мы заимствовали такое программное обеспечение, как Катя. Например, когда мы проектируем нестандартные здания, нестандартные формы, мы также
automotive designs, or we are using this Unreal Engine in our offices. Normally they are used for the animations and filmmakers. So we are borrowing things from the other industries, and I believe that the architects, when they borrow these technologies, which are already tested in the other fields, we come with more creative ways to implement them in our design and construction processes. And in our offices, we have these 3D printers today. We have all the VR, AR, and even the drones we can use in certain design processes. Also, these robotics arms, normally they are very expensive in the factories. They became also available today, where we can start using them in our design processes, not only for construction or for building some And so this means that architecture doesn't only happen on one white paper with your pen and also in front of the computer. Actually, we all can start also having our own laboratories in our offices. And as MAA, Melike Altinisik Architects, we also started as a small laboratory where we can develop research agendas in our office. And one of them was we built an analog tool where we can produce a white concrete cells for a landscape design. Actually, these were a modular system we used. It was very cheap and very flexible system, and at the end we created very complex a landscape design. And here you can see 3 types of white concrete. The stone types were changing, so the porosity of the concrete was changing, and we were using only just 50 by 50 centimeter boxes with a flexible textile on it and some vertical columns we used, so we could get at the end these very smooth and interesting shapes. And here you see like the complete version of this landscape piece. It was 25 meter long and 2.5 meter wide. And another test we did with concrete was this GRC shell. It was built for a architectural biennale in Antalya in south of Turkey. Here we wanted to question, and actually it was called motion in the shell. Here we were experimenting and at the same time criticizing like the way how we use concrete in our buildings and how we can also develop these things by using some molding system with GRC. GRC means glass reinforced fiber concrete. It has some glass fibers inside. So you design actually the 3D model and then you design also the mold of it. You cannot draw here any section or any plan for contractors to build these things. Actually, you need to deliver a 3D information directly. So this means as an architect, you design in 3D and you develop actually the solution also how it's gonna be built. So you need to design the negative of this object at the same time, not only the outcome. And of course, all the process, even though it is digitalized or fabricated with the latest technologies, at the same time there are still like some manpower involved in these processes. So it needs certain developments to deal with this complexity. And in one of the other projects, here again we were using glass reinforced concrete. This was some experiments we did when we were working on our Istanbul TV and radio tower project. This time we were using robotic arms to create the molding for the facade panels. And we did some mock-ups, like 1-to-1 scale mock-ups to check and build if everything is working for our facade detailing. And then we developed all our facade information. And now I would like to go more into detail regarding our Istanbul TV and radio tower project. The story of this project actually goes back to 2011. When the Istanbul Metropolitan Government opened a national competition in Istanbul to replace all these antennas which are located on one of the hills in Istanbul, to replace them with one big antenna tower, which is called Istanbul TV and Radio Tower project. And this here is the main function of this tower is actually telecommunication tower. So it will serve for TV and radio telecommunication. But at the same time, it will have some functions for public to be used for the observation of Istanbul and for restaurants. We wanted to design this building as a collaboration between architect and engineers, because usually this type of buildings are known as the masterpieces of engineers, but we wanted to really combine the two design powers together, and so we wanted to take all the data and information from the environmental conditions of Istanbul. Here, in this another movie, you can see actually like all there are 2,500 different panels on this GRC panels around this tower, and the shape of this tower is a non-standard shape comparing to other TV and radio towers all around the world, because it's using the wind as a important data from the environmental conditions. Here you see an image from the location of the TV tower. It's 369 meters tall from the entrance level to the tip of the project. Here there are public functions and also some technical functions located. The main function of the tower will be this 145 meter tall antenna, and on the bottom part there is an entrance lobby, and here you can see that better. The visitors, when they arrive to the park on this hill, they can choose like 3 different journeys. One of them will be they can come through this path and to this mini plaza here, and then they can enter to the lobby, they can take their tickets, and when they take the elevators, there are 2 panorama elevators which are dividing the tower actually into pieces. One of them is looking at the Asian sites from the Princess Island to the historical part of Istanbul, and the other part is actually facing the north side of Istanbul. And here the second journey will be if visitors come and if they start walking along the green roof, they will have another view of Istanbul from this level. It will be another journey for them, and there will be in the park also some amphitheaters and some public functions where maybe once they come and they visit the restaurant and observation tower, but the second time and the other times when they come, they will be able to use the park for social and cultural activities. And here actually you can see some diagrams which are trying to explain how we were collecting these, especially the wind data and the topographic data to shape the building, because we didn't want to just create a conic 200 meter long conic core and around it putting this spherical volumes. We started from there, but by using this environmental data, we start shaping the tower to find the in-between situation between design and the engineering for the shape of the tower. And here, actually, you can see the way how we developed the podium part for the tower. Here we take the information from the topographical data and we just wanted to lift it to create space underneath this green roof. So it was going to become part of the existing landscape. Here you see some tests we have done for the wind tunnel tests in Canada. There is a very big and important firm. It's called RWDI. They have been doing this wind tunnel test for all the high-rise buildings all over the world. And so we went there, and I have been also during these wind tunnel tests in Canada, in Toronto. And here actually we did almost like 10 different models for to get very different informations. One of them was for the steel antenna part, one of them was for the facade cladding, the pedestrian conditions, the wind and icing conditions, and at the end, when we combined all these things, and when we got the right information from all these data, then we fixed the shape of the building and we continued developing all the architectural details for this project. For us, architecture doesn't only happen happen the nice images you see as a final product. Actually, for us, it's also very important to be able to see what is happening behind it. Like we are using for this type of projects all the BIM tools. You may know what is BIM. It's like building information modeling tools to be able to really coordinate and collaborate with all the engineers, consultants, and subconsultants of this type of complex projects, because around one core all the disciplines had to work at the same time. If one was changing something, the others were affected, so we had to really think smartly and design smartly and construct in a smart way. So usually as architects, when we start any project, we start with the last layer, which we call the facade, and we do the mass studies to be able to create and design the concept of the building. But when we do any design, when we develop any design concept, actually it comes only real when you know what is happening behind this thin layer. So it is really important part and consideration that we need to take while we are developing any concept, because majority of concepts doesn't really come out the same as it started. But if we use the smart tools and smart design technologies, we will be able to really deliver the first sketch as a outcome, as a final building. So these are again like some diagrams trying to explain the BIM project management process we had for this Istanbul TV and Radio Tower project. And here you see like the way how we were segmenting some parts and also different disciplines. We were, even though we were using the same model, we were having an architectural model, structural model, and the facade, and they were all in a way working and collaborating together. And of course, like all these sun-related issues to decide the glazing types or the facade material colors were important for us, and also the degree of different type of GRC panels, how many of them they exist, how we can optimize them to be able to sometimes, you know, we need to reduce the overall budget. And these are again like some other diagrammatic explanations from these BIM tools. Like you have the 3D information, you have the 3D detail, but you get also all the 2D data from these systems. Here on the left you see the build, one of the first built GRC panels when they were moving up, and here first mock-up with the and the drones, I usually show this slide because here what I would like to tell you is we are living in a certain era that actually technology is developing very fast. Like almost 20 years ago, when architects were designing their buildings, the technology development was almost parallel. So when you start from scratch your design, and when it's built, maybe depending on the size of the project, it may take 5 years, but during these 5 years, the technology was not changing that much. So you could take decisions in the beginning and you could apply them 5 years later on the construction site. But today, technology is developing so fast. Actually, for many projects, I believe some part of the construction methodologies needs to be, the decision needs to be taken later. As an example, when we had to put BMU machines on top of this TV and radio tower project, we were doing a lot of researches for the client, and we were telling them, let's take this decision later, because we were delivering for them all these drawings and the bidding documentation in 2015, 2016, and now we are in 2019 and the construction still continues. And we were telling them there will be some other opportunities for the cleaning of the facade, and we were already giving them examples related to drone maintenance. And of course they didn't accept it, and we need to put all the BMU machines on top of the tower. But in near future, you know, the methodologies, the way how we design and take decisions for the construction site will start changing soon. These are again like the same images as I showed you from our GRC panel first mock-up productions. And while we are doing these mock-up productions, of course, on site for construction, we also use these 3D printing methods in the office to be able to see in 3D the way how our building is developing. And we are using these PLA printing machines, and we have also a small aquarium in our office. So if we build like these amorph shapes, it prints in two different materials. One of them is melting in the water, so we need an aquarium to put our 3D print inside that. And in this diagram, we would like to show you the timeline of our construction process for this TV tower. It is using a different method than any other building because here we are building it actually first the basement levels and then the core, and then we built the 145 meter tall steel antenna off-site in 12 segments, and each segment we brought on the site and we put them through this door and we lifted them up inside the concrete core. So like step by step we lifted up and we completed this part. And when the building reached the topest height in this position, some people in the city, they thought that the construction completed, because usually when you reach the top point, usually they think it is done, but actually in our case we were just starting. And later on we built the top part. Actually you see here the final version. We start from the top three, building them on the ground level, and we lift these 3 levels up, and this continued in 4 segments. Currently we finished this part and we are almost in this stage here right now. I will show you some time-lapse video, you will understand it better. Here you can see that 3 levels, 4 levels, they build on the ground, and we lift like these buildings with all the facade cladding, glazing, everything together on top. Currently we finished this stage, and we are moving faster and faster. Right now you can see all the top part of the TV and radio tower project. It's finalized. This is a render actually, but currently the tower looks the same, like this. And this is a view from the observation area. Next year, in 2020, when you come to Istanbul, you will be able to visit the TV tower, and you can also enjoy the view of Istanbul from 400 meters above the sea level. And the next project which I would like to talk about is our Seoul Robot and Science Museum project. In this project, actually, at the end of 2018, Seoul Metropolitan Government announced an international competition for architects. When we saw this announcement about Robot Science Museum International Design Competition, we were quite excited, because there were three important words for me, especially museum, science, and robot together. So for us, this was a chance to really think about how can be a museum for robots, and how can we really rethink about exhibitions related for such a technological museum. So we entered the competition, and when we were doing a lot of research at the same time, because this museum was in Korea, in Seoul, and all over the world when you do the researches, they all say that Korea is one of the biggest cities, important countries who are really doing a lot of investment and developments in artificial intelligence, and at the same time for robotic research and developments. So for us then it was not a coincidence that this robot science museum project was happening in South Korea. So we didn't want to just design a museum where the robots are going to be exhibited. We wanted to really create a new universe and a house for these robots technologies, where actually such a museum can start its first exhibition with its own construction on site. So our design manifesto actually starts with this main idea that architecture itself can become the exhibition by using these technologies. And so these are some diagrams from our competition stage. Actually, we were saying that we can use these existing robotic technologies, at least for facade, for the landscape design, and there can be also drone management on site. At least these three things could happen to really use robotic construction. For us, robotic construction means actually smart construction. And then later on, these robots can be part of the exhibition in the plaza of some of them in the plaza, some of them inside the building. They can be part of the ongoing exhibition. So here I would like to show you a short video to explain what it means for us, the Smart Construction Design Manifesto for this building, and what it is trying to do. Sorry, this. Can you start play on this video? I couldn't. And is there volume here? Can you? So this building will use the smart design and smart construction methodologies. And when we look at around the world, in 90s, digital technology used, 2000, digital fabrication. Today we use off-site manufacturing, but in future we will use on-site construction. So all these digital fabrication tools will help us not only do things off-site, we will combine these things together, and we will be able to have smart constructions on site. So this museum will have this timeline of project and construction, and the construction part will use also smart design for smart construction. We use all these parametric tools where we can control every single thing is linked to each other in our design. When we change one column size, the whole facade is changing, or when we change something in the landscape, even like the spaces are affected. So the exhibitions on site, we want to archive them, because archiving is important for any museum. And since this is such a robotic technology related museum, we will be able to use as examples you can see here, like 3D printing concrete, the site surveys, the rubber bars, all these slab finishers can be done by robots, and also the glazing installations, or there are these kind of AI trackers. For this, you need to have a very smart design to be able to use that project manager kind of doxas, or you can use them for painting, some facade maintenance. So through this, we aim to monitor archive and give it to the people. That's one of the most important things. Like, this museum can be a living museum, because since it's a technology and about robots, it is above all the other things. Like, it can also become a monitoring center for many important sector leaders in South Korea, who can exhibit constantly like their technologies, because right now robotic technology, if something comes out today, 2 months later it's already old, it's already becomes like part of the archive. That's why it should be a living museum. It should have a monitoring center, and it should have at the same time a research center. These are examples to be able to explain like how we vision it. And these are the robots in South Korea, where you can see them in the airport or in some areas. And of course, there will be robots in services, like for guidance, for coffee, or for cleaning at the same time. These are some rendering images from the... this is from the entrance lobby from our museum. Currently, we are in the design development phase of the project, and we are also developing these construction technologies with our client, plus like which companies can be involved in the project takes quite important role. Here you see from the interior of the building, like the design idea, we have some tunnels which connects from the first floor to the third floor to the exhibition levels. We have also some, we call it like eyes, where you can look through from one slab to another. We wanted to increase the curiosity while you are visiting the exhibitions. You can see the education level. Some people are doing getting educated, or when you are in the research lab, you look up and you see some part of the exhibition. So we want to create this kind of connections between the different levels, and this is one image from the exhibition lobby. Here, I would like to take you to a fly-through inside the museum. It's still under development, but at least you can get a feeling of how, when it opens, how it's going to have the architectural parts. Here you see one of the tunnels. Normally here we want to have the digital screen. And in this lobby, you see the circulation becomes also part of the exhibition, and they also represent some technologies, and they can be used for some screenings. We haven't yet put the exhibitions inside this video. Soon we will also develop that part. story ends here, and if you have questions I would like to answer. Thank you for listening to me. Yes. Sorry, Can you give her the? Okay. So. 1 second.
I just wanted to thank you that it was a very nice presentation, very impressive. And I was able to see this tower in April of this year. And of course, I went to see Sinan,
yes,
the
of course.
architect of ancient basically times. But the question is, I know in basically the question is about the health impact of radio waves, because I know that in Austria they did some study, and the telephone towers with different kind of radiation created a very negative impact on people, and they already started questioning the positioning of the towers because cows in Alps started having miscarriages and they stopped producing milk. So it means that if animals react negatively as a health impact, therefore people also have a negative impact from the towers like this. And some people actually report very heavy headaches and migraines. So I think as architects, we are, always innovative. We want to see beautiful forms, unusual, something. But sometimes we forget about their psychological impact and how it creates sometimes disturbances in the architectural landscape, comparing maybe like ancient structures, and people go to see like these beautiful mosques and Sophia Cathedral, and then we have this kind of very high structures, and they dominate the landscape. So did you ever discuss that? Did you guys have any study done about the health issues of the radio waves impacting the city below? That is kind of interesting, because I know European countries, they're already questioning this, and they found some actual unhealthy elements in that. Thank you.
Thank you for the question. Actually, when the government opened this competition, one of the reasons why they wanted to create this high-rise tower, actually, I was showing you one image with a lot of antenna towers. Actually, these antennas are already located on the hill next to the tower that we are almost building right now. And those antennas are located on the ground level, and there are residential areas, of course, around them. The government's main aim was to be able to take this condition in a better situation. That's why it was the point that putting them in one antenna and putting this antenna 200 meters above the hill. So it is already like where all these TV and radio signals start. It's already 400 meters above the sea level and 225 meters above the ground level. This was already one, positive action that before, as an architect, I was involved in the project. The government took this decision. And what we wanted to add on is actually we wanted to use certain materials, especially because there will be also public going inside this building. And so we wanted to, even eliminate more and more this radioactive situation as much as possible we could. So there are these two things were already positively involved, let's say, in the process as much as we could. I wish I had chance to also suggest, another location. But this is, sometimes about the architect's decision, even though we do give the best opinions until certain point they get accepted. And this what I can at least for now answer for this question.
Здравствуйте. Хочу спросить насчет формы вот этого музея. Почему именно форма шара? Как-то, может быть, это обусловлено математическими расчетами? Может, это как-то упрощает монтаж роботами? То есть почему именно вот эта форма? Можете ли вы что-то рассказать об этом?
Sorry, it didn't translate.
Какой канал английский? Можете повторить?
It's not coming.
It's not volume not enough or channel wrong.
No sound here.
Попробуйте еще раз.
Слышно? Получится?
Окей.
Да, получается. Можете ли вы, пожалуйста, рассказать, почему именно выбрана форма шара? Может быть, это как-то математически обусловлено, легче рассчитывать, или там, допустим, это упрощает монтаж вот этими роботами конструкций?
Yes, we wanted to use this type of spherical shape for this building. One of them was we really wanted to create a universe for robots where we can also deliver the message that this is buildable by these technologies, these construction methods. And at the same time, it was also representing for us really the universe for these technologies as I say, as the shape explains the current development that they have, and it is normal for them, to be able to construct something like this. So it's related to each other. It's not easy to build it with manpower, but it is doable with all these digital fabrications and the smart design and technologies. So they are linked to each other.
Hello, thank you for your presentation. I'm an engineer student, and I'm curious about the materials of this building on exhibition. And I would like to know what kind of materials are you going to use. Is it the same materials like in construction without robots, or it's another type of materials? And this building is big, and it should be safety for people. And did you think about engineering part of this project?
Yes, actually, here we will use especially for the landscape part, we will use the concrete, but we will use the 3D print concrete there. Normally, we all use concrete in architecture, not only for the structural parts of the building, we also use it for the landscape, but here we want to use really the 3D printing concrete to shape the surrounding landscape of the building. For the facade, we will use double curved banded aluminum panels, so it will have an open facade system in details, and we want to really bring them almost 5 by 5 meter sizes, and we want to really locate them on the facade. Actually, we will also have a kind of, we call it smart hub on the site, because some robots cannot work on the outside weather conditions. We need to create a shelter for them on the site. We are currently talking about in contact with Hyundai Research and Design Center and Hyundai Robotics to be able to also how to deliver these things really on site. And so some parts will be off-site manufactured, some parts will be on-site manufactured and located on the right conditions. And for interiors of the building, actually, as I was showing, like some things like the floor finishes and these kind of things, they are already done all over. I mean, some parts of the world people are using these things, so we want to combine them together. And I mean, it's not like material-wise specifically using something different, but technology-wise using something different. I mean, if I can explain your question, there are not really new materials in this building yet. Maybe in 1 year, when we finish the project, we might be able to use it, but we need to also discover along the way when we develop the architectural design of the project. Yes.
Простите, что еще раз вопрос. Скажите, это все здания, которые вы сейчас показываете, они невероятны по своей идее, про вложение вашей мысли вот именно в проект. Это что-то свежий глоток воздуха в том, что обычно сейчас видишь. Вопрос в том, вы сами предлагаете заказчику, допустим, такие решения по устройству музея с помощью роботов, или это заказчик предрасположен, как бы зная, что вы такие объекты делаете, к вам, то есть как бы это взаимодействие двоих участников, или это конкретно ваше предложение? Кто инициатор?
Actually, in these two projects, both of them have been competition projects. Here, the client didn't ask us to use as a design manifesto robotic construction. We came up with this idea. They just wanted a robot science museum. And for us, it was not enough. We wanted to, ask a better question for them. Also, for the TV and radio tower project, it was also a national competition project. So there also we came up with all these engineering solutions. Even during the competition stage, we proposed there we need to use this lifting up thing. It was really a design idea personally of mine, that we should use this type of methodology for the TV tower, and today they did it. So they built it with that idea that we built on the ground, we lifted them up. For us, in each project we try to come up with really at least a good question to answer, to develop things. For us, it is important. And we also have private clients, not only competitions. And then the clients come to us knowing that we can deliver to them something different. Not only shape-wise or these things, like as an idea, something different we can come up. It can be an environmental solution, it can be engineering solution, it can be, a different space or feasibility study solution. So we are trying to always think about the future, and at least each project can develop something for the next one. Okay, thank you. So thank you. Okay.
Здравствуйте, я учусь на специальность ландшафтного строительства, и мне вот интересно именно, как подошли к озеленению на данной территории, на территории музея роботов. Какие технологии, может, новые использовались, или какой вот смысловой подход к той же символике?
Actually, for the landscape part of this project, here I cannot really show it, but maybe if I go back, can we go back? If we can go back to the end of, one second. I want to show you one image, so I want to explain from that image the idea behind the landscape of this project. Not which video is this? Maybe you can stop. Oops. If you go back to. Anyhow, I will try to explain. So here, for the landscape, we had this because we had our plot, the area for this museum. You couldn't. Okay, the area, the site that the client provided us for this project was quite actually limited. So. We were going to have very thin, how can I say, stripes of greenery. We wanted to really create a landscape where actually these concrete sidewalks and areas become the landing of this museum shape. So that's why we have a 3D dimensional concrete landscape. And in this landscape, actually the green parts are, in my terms, melting into the green, so into the concrete. So in the 3D printed concrete, we will have here some pots where we will have some greens, but next to it we will have the usual greenery, also stripes next to the sidewalk. So we wanted to melt green into concrete, concrete into the green. I couldn't show it better to you. So in that limited area, for us we wanted to create this transition between the green to architecture, from landscape to the architecture. So I wish I can show you better. And even for the 3D print concrete, when it's close to the ground level green, we will use different porosity of concrete. They will have like bigger stones inside. When it gets higher, it will get like much smooth and dense concrete. So for us, it's kind of the concept from nature to the built landscape architecture. That's what I can with words explain to you right now. Hopefully, when it will be built, I will be able to show in much better ways with photographs. Thank you.
Здравствуйте, спасибо вам большое за выступление. В этот раз вы впервые лично познакомились с Екатеринбургом. И как вы оцениваете потенциал города в развитии в сфере новых архитектурных технологий?
In Yekaterinburg, actually, since 2 days, we have been doing some excursions in the city. For me, this city is important not only with the new built architectures. Actually, it is important with the 100 years ago, all this constructivist movement and the buildings were built with this movement. Because when I was getting my education, architectural education, constructivist movement was very important for me because they were using 100 years ago, they were using the new materials and with high engineering, and they were trying to create something new for the city and for the world. Actually, they managed it because a lot of architects in the past and today, they were really inspired with their ideas, architecturally, socially, also the spaces they created. For me, it's in this city, because of these two reasons, it has very important actually heritage, and I believe this city, if they can use this for the development of the city, there will be quite interesting things will come up. I see some high-rise buildings here built recently, and I see also some mixed-use cultural buildings built with also using some interesting techniques. But if we go back to the original visions that was really planted in this city, I think it has a lot of power for the future also. So this is what I see when I had the excursions around the city here.
Добрый день. У меня такой вопрос. Как использование роботов влияет на стоимость строительства на сегодняшний день?
Actually, the use of robots, when it comes to the situations such as when the manpower is more expensive or it's very dangerous for them to use it, it takes more time because there are autonomous things that people, they cannot do it in an easy way, but the robots or the smart, digital fabrication tools, they can do it. In that sense, you gain time, you reduce labor, and you create safety. In these three manners, I think they will have some important roles in construction, on construction site, by these three main reasons.
Добрый день. Меня больше интересует в плане регулирования законодательством той или иной страны. Бывают ли у вас проблемы с согласованием ваших вот этих вот и внедрением новых технологий, новых исследований, да? Как это согласуется вообще с органами власти, так сказать?
Actually, they want to really have, they want to only use the ones that they have already tested. They have tested approvals. They want to use these, technologies. And also, for example, recently we had problem with drones, because they were not really wanting to use it in that area because there are also residential zones. So we need to get special permits to be able to use the drones because we want to use the drones for the monitoring also during the construction phase because for us it's very important, the construction phase. We want to, archive the construction phase and educate people because all the constructions are happening in the city and they last 2 years, 3 years, 4 years, 5 years. All the citizens, they see something is happening, but they never know what is happening. So for us, it is important to share what is really happening there. And this can become also... That's why we called it exhibition, also during the construction phase. And in that sense, drones are very important, but at the same time, they create problems for the government to use them in that area. We are trying to find solution for that. For the concrete 3D printing, we didn't have much difficulties, but especially for the facade parts, we are trying to find, some tested solutions because they don't want to use something totally new. They want to really get the permission through at least it is tested or done, applied in certain levels, and then they want to apply it on the site. We are currently in that situation to pick up which ones we will be implement on site, like which companies or which ones in detail we will use.
Да, про сертификацию это понятно, да. А как это в плане организации строительных работ? То есть у них же все равно есть какие-то нормы, правила. То есть как вот здесь вот выдержано вот это вот все. Потому что в наше российское законодательство, то есть только сейчас начиная, да, там какие-то действия в плане внедрения BIM-технологий, да, то есть у нас, в принципе, сейчас пока вот на вот это согласование точно не пройдет. В плане экспертизы, проектной документации, в плане дальше...
We are using also BIM for this project because we must use BIM for this project. We need to also design it with BIM to be able to build it on site with these technologies. So there are regulations related to BIM, and these regulations are also related to the construction methodologies, even though it is maybe we are using these robotic arms, but since they are connected to each other through the BIM, so there will be these project managers, they are regulating this process. So they are familiar with BIM through the design and also through the construction. Currently it is in this, what I can answer to your question.
Хорошо, спасибо.
Thank you. Okay. So if there are no questions, I would like to thank you all for listening. Okay, thank you.
Говорю в английский канал, ты должен меня слышать в букву «Л». Слышно? Раз, два, три. Слышно? В первом слышно. А ты мне только что объяснял, что не слышно будут эти микрофоны. Раз, два, три. Раз, два, три.
fraud is accompanied.
Почему Броуд – уважаемое имя? Потому что мы
Какое будущее мы хотим? Потребление энергоресурсов.
Русский слышно? Русский не слышно. Английский канал. Английский канал. Это английский сейчас. Английский, который надо, приходит. Переключать на русский? Русский канал. Говорю в русский канал. Есть. Запомнил, какой канал? Хорошо.
Один, два, три, четыре, пять, шесть, семь, восемь в русский канал. Давай переключай. А теперь я говорю в английский канал. Раз, два, три, четыре, пять, шесть, семь. Угу.
The world's first
Какое будущее?
Один, два, три.
Hello. Yeah, it's good. Oh, yeah. Okay, so, hello, can we begin now? Okay, thank you. I should say, I plan to say Russian. Я хочу говорить по-русски, но не умею. Okay, good morning. Actually, I'm Juliet from China. Our company name is called BROT. So I'm happy to be here. Thank you for your participation. I do hope, you will not waste your time. You can learn a little bit from us, okay? So, BROT, actually, this is the company, it's our headquarters. It's 100 hectares. And the owner set up this company with 3,000 US dollars 31 years ago, okay? So I want you to watch a video so you know what we do, okay?
BROT is a company that exists to tackle world problems. In 1989, to tackle the problem of boiler explosion hazards, BROT invented pressure-free heating boilers and transferred the technology to more than 10 boiler manufacturers. In 1992, to tackle the problem of ozone layer depletion caused by CFCs, BROT invented non-electric air conditioning and has sold products to more than 80 countries. In 1996, to tackle the problem of remote real-time service of air conditioning, BROT invented a global networked monitoring system, which was a forerunner of Internet Plus and IoT. In 1999, to tackle the problem of climate change, BROT invented a new type of air conditioning that uses power plant exhaust to provide cooling and heating, achieving zero emissions. In 2004, to tackle the problem of high energy consumption in central air conditioning, BROT invented the zero-resistance packaged distribution system, achieving an energy savings by 70%. In 2008, to tackle the problem of indoor air pollution, BROT invented the Clean Fresh Air machine, making indoor air 100 times cleaner than outdoor air. In 2009, to tackle the earthquake resistance and energy-saving problems of buildings, BROT invented factory-made steel structure buildings, achieving a 9-magnitude earthquake resistance and 5 times high energy efficiency. The history of BROT is a history of tackling world problems. When the clock of history struck the year 2015, we were greatly surprised to find that in today's world, although construction and transportation industries are embedded with brilliant technologies, the basic structural materials remain quite primitive. This was seen as a critical problem, and BROT was determined to tackle it. In the following 4 years, we devoted more than 1,000 staff and experienced more than 100 major failures along the way, one of which cost more than 10 million RMB in a split second. Finally, we successfully invented the sandwich structural material, the B-core slab. The B-core slab is composed of 2 stainless steel plates held together with an array of extremely thin core tubes through a 1100 degrees Celsius copper blazing process. With just a little knowledge of mechanics, we would understand the sandwich structure is the ultimate structural material with exceptional mechanical properties. However, what is most essential is the B-core slab is made of BROT's original hot air copper blazing technology, which can achieve mass production at low cost. Today, reinforced concrete buildings around the world, though stunning to behold, can only last for a few decades. After all the vanity has receded, the earth is stuffed with construction wastes. The broad-core B-core building is made of stainless steel that is over 200 times more corrosion resistant than carbon steel. Its lifespan can reach thousands of years or even longer, while offering superior earthquake resistance so that human wealth and historical memories can be passed down for many generations. Today, highways span the globe, taking up vast amounts of land and cutting through fragile ecosystems. By using B-core slabs for road construction, even if the road is built completely overhead, it will be at low cost and will have an extremely fast construction speed. Today, various vehicles everywhere use the same structural material that has been used for 100 years. The dreams of generations of car makers to have lighter weight material have never been realized until now. By using stainless steel B-core slabs, we could possibly reduce a vehicle body weight at half and greatly extend a vehicle's service life. Today, ships sailing through oceans are majestic, but their hulls still use the same single-layer steel plate as the Titanic. By using B-core slabs to build ships, even if the hull was knocked down into a few sections, the ship would not sink, since a B-core slab is a sandwich structure that is half as light as seawater. Today, the greatest pride of humanity, aircraft, is actually made of highly fragile magnesium aluminum alloy and FRP or carbon fiber. The sandwich layer is bonded with adhesive and is prone to failure under severe vibration and shock. Aircraft using stainless steel B-core slabs would be 10 times stronger, as well as lighter and more durable. Today, the wind turbine, which is regarded by humanity as the greatest hope for future renewable energy, is made of fiberglass and only has a lifespan of about 10 years. Wind turbine blades made of the stainless steel B-core slab can be at least twice as light as fiberglass to realize power generation with a breeze, and more importantly, can last for generations and potentially stop climate change fundamentally. B-core slab, a seemingly extremely simple structural material, will transform the world's construction and transportation industry from the foundation due to its high mechanical properties, huge size, and low cost. History will prove the invention of the B-core slab has marked the possession of infinite resources, and henceforth mankind has been able to build an everlasting civilization on this beautiful planet where our ancestors have resided for generations.
Thank you. Thank you. So the following, actually, I would like to invite you to travel to our company. So yeah, it's about the headquarters, okay? Okay, thank you. Thank you. So just now you watched the 2 videos and know what we are doing and what we have done. Okay, the owner of the company is Chairman Jiang, this gentleman. Okay, and I forgot to introduce myself. I worked for Chairman Jiang for 22 years. I was the one who brought the company to international market. So I have been in this industry for international market for 22 years. Okay, so I see the development of the company, and I have been to more than 50 countries, giving lectures to people to tell the story of broad. And it's my 3rd time to be here in Yekaterinburg. The first time I came, I brought the video, 30-story hotel we built 9 years ago in 15 days, 15 days. The second time I was invited to this forum, I talked about 57-story building we built in 19 days, 19. Okay? And then the 3rd time, I brought you the new technology, B-corn. This corn tubular stainless steel technology, which can be used for buildings, for road, for car, for ship, for samolyot, airplane. Okay, so this slab can change the construction industry and transportation industry from the foundation. So because I'm an old employee in the company, so I know the story of the company. So I was asked to share not only the products, but also a little bit about our low carbon life. So that's why I'm talking. The first part is about our life in the company, and the second, you will know this kind of people with this kind of quality life can have new inventions. Okay, so Chairman Jiang himself is an inventor. He invented 466 inventions, and he was awarded the Champions of the Earth by the United Nations. In 2011, he was the only one who was the only Asia who got this honor. Okay. And this is the company I talked just now. You watched the video, 100 hectares. We have the eco zone, we have industrial zone, okay? And then we have, so we have all the organic farming here. The employees enjoy the organic food from our own farm. You can see the high rise behind it. Yeah, that is the story, 57-story. Built in 19 days, okay? So we also raise pig manure to produce biogas to cook the food for the pigs again. And the impurities would be good fertilizers. So this kind of cycling, okay, recycling. And you can see all the organic food here. And we have another factory dedicated to our buildings, which is in another city. For that factory, we contracted with local farmers for 32 square kilometers. It's even bigger than Macau. Macau, 28 square kilometers. So we contracted farmers for this land to plant for us. So that's why we enjoy all the organic food in the company, you know, all the things. Even we make our own soy sauce. 6 months fermentation, so all organic things. And we have our own rice, the lease factory, processing, and also we have our own water. Water, we make our own reverse osmosis. People, if they need to enjoy quality life, first they should have quality food, quality water, quality air, okay? Their happiness index would be enhanced. So this is what we do, okay? And our cafeterias, we offer 3 meals to our employees. And these meals, we will tell no pesticide, no fertilizer, no monosodium glutamate. So the food, very healthy for employees, okay? But the company also has very strict policy. frugality is a virtue. You cannot waste any food. The meals bears blood. No need to pay. No money, right? But you cannot waste it. So that's why we have very strict policy. If you waste your food, 2 days, no more meals for you, the penalty. And also you need to pay 200 yuan for your waste. So very harsh. And then we have a mini shop from 1998, so 21 years now. And actually, all organic food from our own farm. Nobody on duty. You do it yourself. It's a buffet style. You buy the products, scan it, and then finance department would check how much you need to pay by the end of the month. So nobody on duty, okay? Credibility. And from 2012, we already began to classify the garbage into 8 kinds. So converting waste into treasures. And also I need to share with you all the buildings we built. We have these 8 kinds garbage classifications. You can see the shining tubes. These are the one we supply for our new buildings, okay? And low carbon bonuses. In the company, if you don't buy a car, you don't own a car, you use public transportation, each month you get your bonus. You have extra money for you for the compensation. So low carbon bonus, okay? And also every year, August 24th is the Broad Old People's Day. If your parents are over 80 years old, you got $1000 US dollars, $1,000 US dollars for your parent. If both your parents got over 80, you got $1000, $2,000 US dollars. Okay, we respect old people. Okay, so yeah, this is the occasion. Each year we celebrate it with this. Okay, and now we come to our key product, low carbon product. We have our air conditioning, which is not driven by electricity. We know air conditioning compressor, actually driven by electricity. Ours, we use natural gas, biogas, or solar, or any waste heat from power generation. So CO2 emissions, 80% less. Energy efficiency, 200% higher than the compressor one. So good for the climate, to mitigate climate change, okay? Number 2 products of the company is air product. We know each person, actually we drink 1.7 kilo water per day. The air we breathe 10 times more. But usually people may pay for organic food, for mineral water. Nobody pay for air. Air is very important. According to World Health Organization, human life expectancy could be 150 years, 150 years. We cannot live to that age because of air pollution. So if you have quality air, you have longer life, at least 30 years longer, okay? You cut your medical bills, you will be happier, okay? The third business of the company is the B core. We say cone tubular stainless steel slab. That can really change the whole world. So I have a video in Russia that introduced the business of the company.
Почему Broad уважаемое имя? Потому что мы сохраняем жизнь. Чтобы защитить здоровье человека, мы создали технологию электростатической очистки воздуха, способную устранять крошечные частицы пыли и убивать бактерии. Мы также создали серию доступной воздухоочистительной продукции, защищающей человека от загрязнения воздуха в помещении, снаружи и в суровых экологических условиях. Что еще более важно? Мы создали приточную вентиляционную установку системы очистки воздуха, позволяющую обеспечить в помещении свежий воздух в 100 раз чище, чем снаружи. Мы уменьшили размеры традиционного промышленного оборудования для измерения концентрации пыли, уровня углекислого газа, электромагнитной радиации, в десятки раз до прибора удобного в управлении и доступного обычным людям, позволяя измерять уровень загрязнения воздуха в любое время, в любом месте. Эта новая технология может показаться не более чем технологическим изобретением, но в реальности она открывает новую эру сознательной жизни. После разрушительного землетрясения в уезде Вэньчуань, провинция Сычуань, унесшего десятки тысяч жизней в один ужасный миг, мы активно и неустанно изучали технологии сейсмостойкого строительства. На второй год мы изобрели технологию строительства зданий из металлоконструкции, способных выдержать землетрясение магнитудой в 9 баллов, предоставляя человечеству возможность по приемлемой стоимости предотвратить разрушение от землетрясений. Мы не только сохраняем жизнь нынешнего поколения, но также делаем все возможное, чтобы сократить выбросы парниковых газов, защитить климат и сохранить жизнь будущих поколений. Назад в 1992 год мы разработали абсорбционную холодильную машину, которая использует топливо напрямую для выработки холода и тепла. Этот процесс позволяет избежать потери энергии от 5 ее преобразований в электрических холодильных установках и значительно экономит потребляемую энергию. Мы перерабатываем отработанное тепло от энергопроизводящего оборудования для холодоснабжения и теплоснабжения с нулевым выбросом СО2. Каждая АБХМ Broad сокращает количество выбросов СО2, эквивалентное посадке 100 тысяч деревьев. Мы экспортировали наши АБХМ в более чем 80 стран. Тем самым сотрудники Broad неосознанно покрыли 4% территории этих стран лесами. А в 2008 году мы неожиданно осознали, что сама по себе тепловая изоляция здания гораздо более энергоэффективна, чем системы кондиционирования. Тогда мы реконструировали все 15 зданий в Броудтаун, добавили теплоизоляционный слой толщиной 15 сантиметров, установили тройные стеклопакеты, внешние солнцезащитные жалюзи и приточные вентиляционные установки с рекуператорами тепла и воздухоочистителями, тем самым сократив потребление энергии в 3-5 раз. Мы распространяли эти простые, но эффективные методы энергосбережения в надежде, что остальные последуют за нами в их энергоэффективной реконструкции зданий. Однако мы с сожалением видим, что важность реконструкции старых зданий не получила достаточного внимания и то, что новое здание строится с еще более высоким потреблением энергии. Из-за этой ситуации мы намерены повышать энергоэффективность зданий, продвигая наше энергосберегающее промышленное оборудование. В следующие 5 лет, выделив более 2000 сотрудников и более 4 миллиардов юаней, мы создали модульное устойчивое здание, которое мы назвали BSB, с более чем 10 энергосберегающими технологиями, движимое сумасшедшим энтузиазмом. BSB в 5 раз более энергоэффективно и производят лишь 1% строительных отходов. Сегодня строительство и эксплуатация зданий потребляет половину энергоресурсов планеты. Мы смело мечтаем, что однажды весь мир будет использовать технологии устойчивого строительства Broad и сократит количество выбросов СО2 на 40%. Если этой мечте суждено сбыться, Земля будет в безопасности, и наши будущие поколения смогут обеспечить свое проживание на этой прекрасной планете.
Thank you. So actually for Broad, we have 24 world's first inventions. We know in China there is a Huawei technology, right? And also for us, Broad, we always develop something the market needs desperately and others cannot make it. So we have 24 items. We have the first invention, the inventors in the world. And actually in 1998, I set up the international for the whole group, and I have been the international CEO for the air conditioning. I've been the international CEO for the air products. I'm the international CEO for the buildings. So that's why we are in more than 80 countries for this air conditioning, okay? And like this air conditioning, just now I mentioned, not using electricity, but natural gas, biogas, solar, or waste heat from power generation. So energy efficiency is pretty high, CO2 emission 80% less. So like the 1999, we developed the first one in the world, the flue gas air conditioning. So that means if we generate power, only 35% efficiency or 40% efficiency. The rest, 60%, is wasted in terms of flue gas or hot water. What we have done here, we recycle that flue gas, we recycle the waste hot water to make free air conditioning. So in this way, the operating cost is free. No need for you to pay because it's waste heat, right? And CO2 emission, 0. We recycle the waste heat, so that's why it's very environmental friendly, okay? And the first one we developed, it was purchased by the Americans. The US Department of Energy purchased this one, okay? And then the biggest district cooling project in the world is in India, in the suburb of New Delhi. It's a city called Gurgaon, Cyber City, okay? We sold 46 units to them, and less than 2 years, we got the payback. It's all waste heat from power generation. And it's my biggest purchase order in my career because the value, $100 million, okay? So this one equals 22 million tree planting. That's the contribution to the environment, okay? The whole city is air conditioned by Brad. We also sold many air conditioning units to Russia, okay? Like this Rigaland in Moscow, we sold them the units from 2008, okay? And then cover much area. So we also have many other cities, like even Yandex from Russia, they're using our air conditioning. Second business is this air product. Just now I mentioned eradicate indoor air pollution, okay? So actually I have a measurement, a meter here. This is the air monitor. When I come here, I want to see how about the air quality here in your country. It's good. I should say congratulations, because you see, like in this convention center, 2 microgram per cubic meter air. This is superb, okay? According to World Health Organization, developed countries like US and Europe, 20 microgram. It's up limit per cubic meter. You got 2, it's good. Outside, I measured 8 microgram, okay? And also we have another measurement. It's 1 liter air, how many particles? Here, indoor, it's 10,000 particles. Outdoor, it's like 80,000, So still there is a difference. But all our buildings we built, indoor air should be 100 times better than outdoor. So for example, for ours indoor, if we calculate the weight, microgram per cubic meter, it's 0, okay? And then outside, like yours, 8 or something, right? 8 microgram. You would see, 8 times difference. Actually not, because we have another measurement. 1 liter air, how many particles? Usually in our building, like 300 particles. And here, 80,000. You see the difference, So that's why, 100 of times difference. That's why we make this measurement to let people see. Air quality is good. Indoor air, oxygen not enough. It's another issue. So that's why 99% of the buildings in the world are sick buildings. Why? They're suffering sick building syndrome. According to the American air conditioning design, 30% fresh air, 70% used air. So that's why if I got a cold, I may pass it to you. Why? Lacking of fresh air and also cross-contamination. But in our buildings, 100% filtered fresh air. So that's why we solved that issue, okay? And this air product, they are using in China White House. It's like your Kremlin, you know. So it's China president enjoys the quality air. And also the APEC venues, they're using our products, okay? And Dubai Mall, the largest mall in the world, they're using this. So the third business, which is called Broad Sustainable Building, we have a dedicated factory. It's 130 hectares, and we have 230,000 square meters for the workshops. So all the workshops you can see solar roofed. We have the solar panels there, okay? And I want to introduce this beacon. This is the latest technology, okay? And this really changed the world. Actually, it's only 2 panels and with the tubes together, copper brazing. So you see we have the oven. This is the core technology. 1,100 degrees C, the oven, okay? And we have the slabs inside, copper brazing here. So we invested 8 billion renminbi for this new technology, okay? So that's why we are also looking for partners worldwide, especially in Russia, we are looking for partners. So with this, actually, every 4 hours, we get 240 square meters. People would think, wow, you use stainless steel to make the buildings. That should be cost much more. No, we don't. Why? Because we have mass production. We can lower the cost. That's the magic, okay? We can make affordable pricing for people. So, yeah, I'm going to talk more. Yeah, this is the one.
The world's first core tubular stainless steel CTS slab building. All components were factory made with an on-site construction time of 24 hours. It's 10 times lighter than traditional buildings and can resist any kind of land subsidence and earthquake. CTS slab consists of 2 steel panels clipped with thin wall core tubes. Welded as a strong structure at 1,100 Celsius degree, huge capacity, yet moderate cost increase. In comparison with traditional buildings, the lifespan of CTS slab building can be 100 times longer. Not only can CTS slab be used as building structures, but also road, bridge, elevated road, vehicle or aircraft covering part. The weight is reduced magnificently, while consuming only half the energy. As a material supplier, Broad provides the global construction and transportation industry with high-quality and low-cost CTS slabs. The world is changing.
Okay. Yeah, so we have completed more than 50 buildings. To be exact, 59 buildings we completed. The tallest one we finished 57 story. The highest one we got the approval from Chinese government is the Sky City, tallest one in the world. It's 10 meters taller than Burj Khalifa, 838 meters tall, 202 floors, okay? And then the latest technology with this 16 story, you can see the third picture. This is the one we newly finished, 3 stories per day, 16 story, okay? And 1 week we completed. We call Green Tree Tower. Why? It looks like a tree. At the bottom, it's smaller and the up larger. So the bottom is 150 square meter and the top 1,100 square meter, 7 times larger than the bottom. And we have all thermal insulation for the building. So with this slab, actually the one I show you here, this one is not for the buildings. This is for car, for aircraft. So very thin. The one for the building, thicker than this. And we have rock wool for thermal insulation. So for this building, actually it's thermal insulation. We have 15 centimeter, you know. In Moscow or Yekaterinburg, we need to have 30 centimeter. We would have thicker thermal insulation, okay? And also triple pane window for this building. But for here, we need to have 4 pane glass windows, 4 layers for the window. So energy efficiency pretty high. And each square meter per year, you know, energy consumption is 100 kilowatt hour. Similar building with this would be 500 kilowatt hour. So our building energy consumption is 1/5 of the conventional one. Very energy efficient, okay? And also, you know, for this, you know, it's stainless steel, so it lasts from generation to generation, okay? Lasts pretty long. And I want to summarize the features of our building. Number one, 100% factory made. We all made in the factory. So that's why we design it, you know, like an aircraft, super light. We also have the streamlined production. So like automobiles we are producing. And then we have well-trained workers. You see, globally in this construction industry, people use contractual workers. Today, they do not have the work to do. They return to the countryside. Yeah, it's farmers, Kristiani, right? Farmers. Tomorrow, they come to the construction site to become construction workers. So nobody is responsible for the quality of the work. But here, we have our own regular member. They work here 10 years, 20 years, 30 years, okay? So they are reliable, trustworthy, well-trained. So this makes the difference. Number 2, 3 stories per day. Every day, our speed, 3 stories per day. So that's why we have, you know, installation like Legos on site. You can see people, you know, actually it's also worker-friendly environment, no dust, you know, good for the workers' health. And number 3, actually minimum weight, freight. Why? Because the slab is 12 meters long, 2 meters wide. So the floor slab and column, if we place vertically, and also beam horizontally, the same. We use the same slab to make the floor slab, to make the column, to make the beam. And also they can be containerized. We can put in a 40-feet container and ship it worldwide. So all the buildings can be flat packed, okay? So that's why the shipping cost is pretty low, okay? So one 40-feet container can accommodate 480 square meters. And also number 4 features, energy efficiency, 5 times higher. That means only 1/5 of conventional energy consumption in our building. Why we can achieve this? It's because we have thermal insulation for the wall. Just now I mentioned we use rock wool, 15 centimeter to 30 centimeter. We have 4 pane glass windows. We use external solar shading. We use fresh air heat recovery. And we use on-site power to provide free air conditioning. We also have the lift elevator, which is auto power generated lift. That means if the lift is empty, goes up, it generates power. Full capacity descending, it generates power. Initial investment for this kind of lift is 10% more. Within 1 year, you got the payback. So we have this special lift. more than 30 energy saving measures are used in our building. So that is why we can have 5 times energy efficiency higher than conventional one. For example, like this 30-story hotel in 2011, we built in 15 days, 15 days, energy consumption is 70 kilowatt hour per square meter per year. Similar one would be 350 kilowatt hour. So 1 year, you can save 8.8 million kilowatt hour electricity. That equals 730 ton oil saving, and that equals 2,000 ton CO2 emission cutting. We know each tree can absorb 18.3 kilo CO2 emissions each year. So 2,000 ton CO2 emissions we convert into tree planting. It's 110,000 tree planting. That's the contribution we make to the environment. Number 5, features for our building. Indoor air, 100 times better than that outdoors. Just now I mentioned, you use this measurement. You see, for example, like outside is, in China we have poor air, 75 microgram per cubic meter is the upper limit. But we usually have 100, 200 microgram. Extremely bad, okay? But in our indoor, 0. Or we say 1 liter air, less than 1,000 particles. Extremely clean, okay? So that's why we guarantee 100 times cleaner than outdoor. This is a feature for our buildings, okay? And number 6, magnitude 9 earthquake resistance. No collapse during magnitude 9. We did this testing at China's Academy of Building Research. It's the second largest testing platform in Asia, okay? I don't know if I have time for this video or not. We can see how we tested. It's number 2 in Asia, this testing platform.
工况42开始。工况43开始，海面700。
Okay, that's it for the earthquake. So some people say, in my area, no earthquake. Who knows, right? Earthquake is unpredictable, but these buildings are defensible. We have only one life, right? No one would like to be tested, so it's better to be safe than to be sorry, okay? And number 7, it's low cost and worry-free. So we can be the EPC contractor. You know, some people may question us, do you have the qualification in Russia? We don't, frankly speaking. We can have the partnership with the local construction company who have the qualifications, okay? We can only be the building suppliers, and then we would also try to together to meet all the local codes. So we have the capability to be the EPC contractor. So in this way, yeah, we can eliminate the common budget traps, the over budget traps, okay, the quality disputes and the construction delay, and also potential corruption risk. We don't have all these things, you know. So customers enjoy affordable pricing, you know, low cost and worry-free. Number 8, eternal wealth. We say eternal wealth because this B Corp outlive concrete and carbon steel by 100 times at least. So this can be passed from generation to generation. Chinese parents spend all their life savings to buy an apartment for their children, you know. But actually that lasts only 70 years or 100 years, you know. With this one, 10,000 years is a generation legacy, okay? So that's why this makes a difference. And also, for this theme of this 100 plus forum, I know it's the future city. Actually, for our buildings, we have 5 times 3 principle. I want to share with you. It's this, our buildings, intelligent planning, okay? We have less transport reliance, and then less land occupation, and more green space for people live in that building. And secondly, it's intelligent material, better earthquake-resistant performance, longer service life, and less harmful materials. And this is number 2, okay? And then intelligent, smarting construction, less on-site construction, less physical labor, and lower quality risk. And number 4, intelligent efficiency, less thermal energy loss, and higher electromechanical efficiency, more available and effective renewable energy. Okay, and last is intelligent comfort. Why? Better air quality. Just now we mentioned we guarantee 100 times better than outdoors air, higher thermal comfort, and better sound insulation. Okay, so we have a 5 times 3 principle for our intelligent buildings. These are 5, okay? And some of the job references we would like to share with you. The first one in the world, 3-story, we built in 1 day, 10 years ago, okay? And then we built 6-story Shanghai, at Shanghai Expo, and then 6-story in 1 day. And actually, during the Expo Shanghai, Pavilion of Russia, air-conditioned by us. We supplied 250 pavilions with our air conditioning. So that's why we made contribution to Expo. Chinese government listed our pavilion as Expo Heritage. It's still in Shanghai. If you would like to visit, you can write to us. We can arrange the visit, okay? And then some other references all over China, okay? Chinese Medicine Center, actually, because hospital and schools, they like our buildings because of хороший воздух, quality air. The air is like the ICU air. So that's why they often select us. And also you can see the museum here. The facade is different, right? People can have a secondary facade as long as it's 100 kilos per square meter. Externally, exterior wall, they can put marbles, they can put PV panels, as long as the weight is 100 kilos, okay? And also some other places, we had all this, it's mainly on the Silk Road, Belt and Road, And this is COP16, the climate change conference. We know Paris climate change, right? But many young people may not really remember because that was like 9 years ago, okay? So COP16 was held in Cancun, Mexico. So we built the pavilion there, and Mexican President Felipe Calderon inaugurated that one. Myself, I was involved from scratch to the end. So I was also there for the ribbon cutting, okay? And also the New Ark Hotel, we built in 1 week, 15-story. Like Jack Ma, the richest man in China, he stayed 1 week in this hotel. So you can see the photos here. Jack Ma liked this hotel very much. And 30-story hotel we built in 15 days. Yeah, it's 2011 we built this. Changsha Convention Center, near the Bullet train station, yeah, we built this one. It's operated by French people now. It's called Ibis, okay? And some others. And 57-story, we built in 19 days. It's 180,000 square meters. So I want to know how many of you watched this video on YouTube? Can you put up your hands? 1, 2, 3, not many. Okay, so it's worthwhile to watch again, 3 minutes, okay?
Okay, thank you. Yeah, so we come to the Bighorn House. It's a 4-story we built in one day, but the interiors, 1 floor, 1 day. So the 4th day, you can move in and sleep there, okay? And then, you know, Foxconn, they are the iPhone supplier for the parts. They come from Taiwan. Terry Gore is the richest man in Taiwan, and he likes this kind of building. He purchased one from us and installed on their campus in Shenzhen, okay? Foxconn building. And with this slab, we also built an experimental bridge. We built a bridge here with this slab. So we have this, we built this building for Foxconn. We invite you to watch it. So the slab vertically is the column. You can see 12 meters long, 2 meters wide. They are the same. So Terry is here. Terry Gore, the richest man in Taiwan.
We have a whole factory. We actually are actually a second factory in here to just to meet the
Okay, so that is the 4th story we built in one day. We have a bridge. For the bridge, we can shorten the time and the price can be more competitive than conventional one. So this is an experimental one. Okay, thank you. And the following, I want to share some of the reports on our buildings. So this is the Innovation Award we got in 2013 from the Council on Tall Building and Urban Habitat. They are headquartered in Chicago. We know Chicago is a city full of skyscrapers. So this award is called the Nobel Prize of High Rises. And Reuters interviewed the owner of the company, and Harvard Business Review talked about our buildings. And Financial Times from London and McKinsey, Rethinking Conventional Construction, okay? And Bloomberg Business Week interviewed me and wrote a report. And Mexican president delivered a long speech entitled A New Revolution in the World Architecture Industry, okay? And former US Secretary of Treasury, Henry Paulson, wrote a new book dealing with China, chapter 18, talking about abroad and the buildings. And the World Economic Forum Annual Report 2016, talking about our buildings. UN Secretary General Ban Ki-moon in Rio 2012, he talked about our buildings. He listed 4 companies that made great contributions to the environment. Microsoft is one, Broad is another. And Ban Ki-moon, last week, he came to visit us and visit our building, and he was so much interested in that, And then we invited him to open Asia Pacific Forum on Low Carbon Development, which was held on our campus, okay? And for our beacon can also for the bridge, for the vehicle, for the ship. We are only a supplier for the material. And for the wind turbine, I should tell you the good news. For the wind turbine, nowadays the blade is made of fiberglass, pretty heavy and lasts no more than 10 years. For us, we can make with our beacon slab last thousands of years, and weight super light, and cost the market price with ours is only half of the market price. And even with breeze, slight wind, we can generate power. We are sure we're going to flood the market with this, okay, for the renewable energy. That should be the future. And also with the aircraft, with this slab, super light and super strong, can be used for the aircraft, okay? So the benefits of this beacon, technical benefits, social benefits, investment benefits, and environmental benefits. Every square meter we built, we cut 90 kilos CO2 emissions. That equals 5 trees we planted, you see? So this kind of slab creates everlasting civilization, okay? And our strategy is we are looking for partners worldwide. So either joint venture, either franchisee, either sales or distribution agent, distributors, okay? And so, yeah, we are looking for partners, okay? And they can be used for the building, the road, bridge, and, so 9 industries. So the construction and transportation industry, we plan to convert, from the foundation. This is the last video.
Какое будущее мы хотим? Потребление энергоресурсов, сниженное до трети, четверти или даже до 1/5 современного уровня. Энергосбережение – это ключ к свежему воздуху, безопасному климату и стабильному будущему. Устойчивое строительство Broad сокращает энергопотребление на 80%. Холодильные машины Broad используют в качестве источника питания отработанное тепло.
Use regenerated heat. The slab, units remove particles by 99.9%, regenerating 80% of energy. Broad Group creates the future that the humanity wants.
Thank you. Yeah, that's all for my presentation. I would like to leave 20 minutes to open the floor for questions and answers, okay? So anyone has the question can put forward the question.
Да, здравствуйте, я здесь. Здесь. Да, меня зовут Ульяна Нигматуллина, и у меня такой вопрос. То есть я так понимаю, что у вас вся конструкция здания, она состоит из металлических структур. То есть это и пол, и колонны, и в том числе и стены из панелей, да, которые состоят из металлического каркаса. То есть получается, что люди, которые
Excuse me, I didn't catch the translation. Yeah, it's because. Yeah. No sound from that.
Скажите что-нибудь. Да, вы меня слышите? Вам переводят?
Or someone can do the translation on site. They have okay. Yeah, okay. What is your?
Да, появился перевод?
Can.
Ага, хорошо, спасибо. Меня зовут Ульяна Нигматуллина, и у меня такой вопрос. Я так понимаю, что все ваши здания, они полностью состоят из металлических конструкций, то есть это и перекрытия, и колонны, и поддерживающие структуры, и стеновые панели, они все состоят из металлических структур. То есть фактически получается, что люди находятся в некой, условно назовем, консервной банки, да, полностью запечатанной. И, соответственно, внутри будут образовываться какие-то электромагнитные поля. Вдобавок к этому примешиваются излучения от аппаратуры, от кабелей и так далее, от всего этого обеспечения, которое находится внутри здания. И проводили ли вы какие-то измерения электромагнитных полей и волн, которые образуются внутри, и как они могут влиять на людей, которые будут находиться в этом здании, и в том числе, какие будут образовываться поля внутри вот таких вот конструкций. Спасибо.
Okay, this is a good question. A lot of people question that way, but actually no impact, only the signal. Let's say the cell phone. Maybe, you sometimes the signal is poor, but actually for humans, we already did the measurement, and also because you have the indoor comfort from our air conditioning, the quality air from our equipment, so that's why indoor, very smart comfort. Just now I introduced in my lecture, actually, know that kind of impact, okay? Yeah. Have I answered your question?
Ну, на самом деле не совсем, потому что известно, что от телефонов есть излучение, которое не совсем благоприятно для человека, и от тех же Wi-Fi передатчиков, да, источников тоже есть неблагоприятное излучение, и давно уже рекомендуется отключать, допустим, на ночь и телефоны, и, допустим, те же передатчики Wi-Fi, а в таких вот структурах, которые полностью из металлических конструкций состоят, то есть, грубо говоря, мы запечатаны, которые не пропускают воздух ни туда, ни обратно. То есть как будто внутри, на мой взгляд, да, все вот эти вот волны, они там находятся и никуда не выходят из этого здания. То есть постоянно присутствуют, да, циркулируют внутри этого здания. Вот эти все электромагнитные волны и каким-то образом там наверняка еще преобразуются. То есть вы этот вопрос не изучали.
No, actually, I should tell you that your worries no need for you to worry. You know the Empire Building in the U.S. in 1931. 1931, they already used the steel structure to build the World Trade Center, also the steel structure. So actually, we are used stainless steel. So actually, not much impact on the humans. So this. It's more and more people using this kind of carbon steel for the buildings. So that's why we all studied that. What you mentioned, actually, not much impact, I should say. Yeah. Here.
Добрый день, Зелень.
Yes.
Город Пермь. У меня...
Can't hear it right. Okay.
Использовали ли вы ваши плиты в мобильных каких-то комплексах для развертывания их в зонах чрезвычайных ситуаций, там пожары, землетрясения и так далее, разборные какие-то? И как, если это было, как вы туда их доставляли?
I should tell you this beacon, what I displayed here, it's the new technology, okay? So that's why, this can be used for the mobile housing quickly. As I told you, 4-story we build in one day, and then we use interior 1 floor 1 day. And so that's why it can be done very quickly. Because it's a new one, so we have not yet done this kind of mobile housing. The company, we have the policy, we focus upon high rises for more concern of the environment, save the land, save the resources, energy efficiency. So that's why we focus upon high rises instead of this kind of mobile housing. Can be done, definitely. Thank you.
Скажите, вес плиты сколько? Можно ли вертолетом доставить?
Okay. Well, if you use helicopter, that's too costly, isn't it? Yeah. Well, the weight, actually, I can tell you, the 4-story we built on the campus of Foxconn, 4-story, it's 326 square meters total, 82 square meter per floor. That one, 36 ton, the whole building. We can hook it from one place to another, but not by helicopter, okay? Yeah, so that's super light. I can tell you one slab, 24 square meter with the rock wall, it's 1,100 kilos, this slab. If without rock wall, 850 kilos. So it's super light, okay? And also, thermal insulation like this 15 centimeter for the thermal insulation for our building equals 3 meter for concrete. So that's why energy efficiency super high, okay? Yeah.
Спасибо.
Здравствуйте. Hello, my name is Eldar Absalamov. I represent Kazakhstan. I'm a designer. What is the thermal temperature impact on the structures? What is thermal impact could be even higher than seismic?
One translation. Yeah, sorry. Yeah, okay, can you say that again? No translation just now.
Seismic thermal impact, can you hear me?
Yeah. Yes, I can now.
The impact of thermal energy, the heat impact could be higher than seismic. Have you made any kind of research regarding this high temperature impact on the stainless steel structures?
No, actually we did the, heat transfer for the wall. It's 0.4 K. It's the K value, heat transfer efficiency, 0.4 watt per square meter. So it's a similar one would be like 1.2, watt, much higher than ours, So seismic, actually this is anti-earthquake,
Повторить можно? Можно повторить? То есть я имел в виду, что при пожаре, допустим, металл имеет свойство расширяться.
Oh, okay, fire protection you are talking, right? Are you talking about fire protection? Yeah. We meet the national standard. Currently in China, we have all the standards. We meet that. If we want to come to Russia, we must meet your local standard. We have the treatment of that. Okay. Yeah, over there. Yeah.
Здравствуйте, я прослушала выступление и осталась с таким вопросом. Я не совсем понимаю, за счет чего обеспечивается скорость возведения здания и что нужно сделать, чтобы в России строили так же быстро.
Then you need to have our technology, right? Yeah, because we 100% factory made, We did everything in the workshop. So that's why it can be faster, Did you catch?
Таким образом, суть скорости состоит в том, что именно в материалах она заключается, скорость ваша. В новых материалах ваших.
It's the design, and also, I should say, the configuration, our whole system, that makes, it's mainly we do in the workshop, not on the site. So that's why we can achieve such kind of fast speed.
Спасибо.
Okay, yes. Yeah, here.
Насколько понимаю, у вас высокая заводская готовность конструкций. А как это вы используете информационные технологии при их производстве или что это? И как маркируются они или какие-то датчики на них стоят, чтобы на площадке быстро собрать здание? Или просто все одинаковые плиты, поэтому без разницы, куда ее ставить и в каком порядке?
No, actually, each part, we have very strict production control. And actually, each part we should be checked and double-checked, And also, even our workers, they have a sense of pride. Because that part, the work was done by him, his name will be there. And then he will, this building, actually part of that is done by me. Everything, we have this kind of computerized the kind of system to do this kind of management, And also the design, we use BIM and we use some other software to do, Yeah. Have I answered?
Спасибо.
Спасибо. Any more questions? Nobody talk about the price? Сколько денег? No? Okay, yeah.
You know about isotrust technology?
Which technology?
Isotrust. In the USA, they made this material.
No, I'm sorry. It's made of what?
Don't know about this, yes?
No.
This.
Yeah.
This material most strange and most lighter than steel. And I think this material very good for building. Why you don't use this material?
We want to use the material that people can afford it, If that material I've never heard of, excuse my ignorance, and also maybe most people cannot afford it,
Just read about, please. Just read about this material, please.
Okay.
And just think about it. Okay. It's a good idea, I think.
Okay. Thank you.
No problem.
Здравствуйте, меня зовут Александр. Расскажите, пожалуйста, делаете ли вы какие-нибудь кастомные формы на заказ для материалов? Не обязательно стены, а просто какие-то конструкции, которые можно использовать в качестве исходных частей для арт-объектов или каких-нибудь других вариантов.
Are you an architect?
Да.
Okay. Good question. Okay. Thank you. Yes, we can make it. We can have tailor-made. But I should tell you, the price would be sky high, So what we want to, make buildings for most of the people so they can be affordable. It's an industrial product. So we have our standard design. 16 floors, 32 floors, 24 floors, this kind of standardized. So they can be cookie cutters everywhere. So customers can have interior decoration by their own, or exterior wall. They can have other decoration. But the structure and those, we standardize it. Otherwise, people cannot afford it, We want to make it a kind of industrial product. So that's why technically we can do it. The only thing is we don't want to do it because we want to please most of the people, okay? Yeah.
А вот какая будет минимальная партия, скажем так, которая не приведет к сильному удорожанию, чтобы перенастроить конвейер или, что у вас там?
Okay. It's because of the modules, the mold. We have 12 meters long, 2 meters wide, If you have that kind of artistic shape or what, we need to cut a lot of materials, waste the materials. So that's why, and also we should have special team to redesign all this, So at this moment, we still don't want to, have this kind of customer built, We have the capability. We also need more architects like you later to work on this tailor-made, okay?
Хорошо, я могу оставить вам телефон.
Okay, good. Yeah, you see my email address is there. Can write to me, okay? Thank you.
Здравствуйте. Я так понимаю, что вы стремитесь к максимальному типизированию своих проектов. Сталкиваетесь ли вы с такой проблемой, что здания с архитектурной точки зрения становятся тоже типичными, похожими друг на друга, подобно панельному домостроению?
You have, yes, many people question me that. It's similar. It's all square. Yeah, they're similar. And actually, it depends how you see it, There is no taste in, there is no talent in taste, okay? Each one, 1,000 readers, they read Hamlet. They have 1,000 Hamlet in their minds, But in our opinion, this kind of square one, simplicity is the beauty, okay? Because it's affordable and environmental friendly and lasts forever, that kind of legacy, generation legacy. So we think future cities need this. Humans, if we really want to mitigate climate change, we need to sacrifice something, That's what we think. Each company has its own philosophy. So for us, whatever we do, we have a slogan, brought for humanity's future. That's what we are doing. Okay? Yeah. Thank you.
Спасибо.
Thank you. Yeah. That time is up. Yeah, I actually. Oh, you still have. Okay. Yeah. I mean, someone needs some materials. I have a few copies here. Can give it to you. Okay. Yes.
Government helps your company.
Up till now, we didn't apply any support for. We spent 8 million Chinese currency from our own pocket. But we are trying to get more support from the local government. But because the company itself, we start with $3,000, and actually for 13 or 15 years, we don't borrow money, we don't lend money. We have very good financial, this kind of situation. So yeah, if we want to make it bigger, to be number one, we definitely need more support from the government. and also need more support from people, friends like you here, right? Thank you. Yeah. Okay. Yeah, okay. Thank you very much. And we welcome you to visit us. Seeing is believing, okay? Spasiba. Come to weigh this, super high, super low, light, and super strong. Okay. Super light,
Говорю в русский канал. В русский канал говорю в русский канал.
Русский. Русский в английском канале? Вот крути сейчас, чтобы он... он в английском канале. Бум. Русский в английском канале. Русский в английском канале. Английский.
Good afternoon. Can you hear me well? Good afternoon, dear friends. Thank you very much that you came into this hall. Thank you very much to the forum 100 plus. So I just estimate this forum as a successful example of communication and interaction between the experts, specialists, and just all people interested in high technologies. I remember initially this forum was only about high-rise buildings, but now we have quite a wide agenda, and this is very interesting. Today we have two guests in our hall. So the representative from China, Juliet Jiang from Broad Group, and Kira, so the representative of company Princip, Ekaterinburg company. And I'd like to discuss today, in my opinion, a very important tendency which is happening all around the world. It is how business, development and construction is associated with urban development, planning and development, and its interaction with architecture and aesthetic principles, how successfully they combine together, how successfully modern developer, modern architecture can interact with the positive result. On the one hand, we can understand that the growth of the population is going on exponentially, and in 80 years there will be 12 billion people. This is quite a big number, and we have to be ready to that fact, because the only places of residence will be cities, and they will attract all human, political, economical resources which will need successful management. And the question arises is who will do it, who will manage these resources, and what the experts' roles will be to regulate the resources. And on the other hand, just the producers over those whose work is associated with architecture, so starting from the developer to the producer. And this is a huge responsibility because we live on the same planet. And I remember an example of my Swedish colleague when I asked him how to explain that the human being is responsible just in front of all humanity, that he should carefully just work with resources, and he shouldn't do anything extra. And he gave me a simple answer. He said that that's impossible to explain to an adult person because it's too late, but we can explain this to children. And the example that he gave to me concerned the program which was conducted by his institute, DWL, about technologies and environment. This project was done together with the school institutions, and they made a program just telling about technologies. And there was a case for the children. And they said to children to imagine that they were in the space ship, and what is inside are the final resources, and that they will not have any more resources. They had only just water, air, some construction materials. So we can look at our planet as a spaceship. So we are in the enclosed environment, and the resources are limited, and we need to just renew these resources. And these questions, these issues are fundamental from the point of complex approaches, and we have to develop the cities and the infrastructure. So 10 years ago, when Skolkovo started its work, we discussed alongside with Skolkovo the formula which could raise the issues concerning ecology, power, how it will impact the economics. So we suggested the 4E formula: energy effectiveness, ecology, efficiency and economics. And then we added one more E. The fifth E is emotional aspect. When we just designed the construction of Skolkovo, this formula could be as the basis to the approach of developing a new project. So we cannot imagine the city without emotional aspect, because that's an important aspect to evaluate the city, its beauty, its attractiveness. So you can look at the city like gray or white or stone made. So, but the basic principles like effectiveness, economics, and ecology, how the person can feel just inside. So, and there are not so many developers who use these ideas and this. Anyway, we made a model, and we could understand that in Russia there is no standard regulation which can define the approaches to implement urban and rural infrastructure. There are a lot of approaches, green standards, and many different initiatives trying to just implement at the legislative level. And that's an important issue because later on it could be too late. And all the previous standards don't work nowadays, and developers can't deal with the Soviet standards, which they have nowadays. So in which we have in the urban planning code. And of course, we need a new standard to create. For example, in America, there is a LEED standard, so the standard of energy efficiency. In the Great Britain PRIAM standard, there are some European standards. So the German one is the most perspective one, with including some social aspects. So we made a conclusion that we need such a standard. This is a huge work to be done, not alone. And Skolkovo as a center couldn't solve this problem because there are a lot of investigations to be done. But anyway, we all need that standard. And just if we go into history, so where we could apply that standards, I will mention very briefly main tasks of 5E. So these are world-level tasks which are important not for only one country, but for many countries and for every human who works with design. For example, ecology is just the impact of the construction of building on the planet climate. So we know what is happening in the world, and there are two groups in the world. So one group of investigators say that there are some climate changes in the planet. So the second group say that they cannot see any climate changes, and this is only a political aspect. But really, we can see climate changes, we can see weather changes, and there are some disasters in different parts of the world. Of course, we maybe don't know how well it is connected with the human activity. For example, in California, due to the dryness and fires, Los Angeles is very close to the to be burnt out, so the fire is very close to the city, and it happens every year. And if we talk about human impact on the environment, then of course this influence is associated with industrialization, with the development of big cities, with the construction of different production companies, with disposals and inappropriate processing of the just waste products. So, and of course there is an issue of using the energy or renewable energy, and we all know that our country is the position where when we use oil and gas as quite cheap source of energy, and we know that many European countries we lack of resources, and they try to be independent and try to develop new technologies, and these technologies are expensive nowadays, but with every year they are becoming cheaper and cheaper, and very soon we might refuse from the energy automobiles, so vehicles, and will use just automated automobiles. So, and for example, every house should generate the energy and become an active object. And in the Germany, there is a particular program with active houses producing power, energy, and it is associated with state regulation and infrastructure regulations. And I hope that sooner or later federal authorities will pay attention to this problem, and in the nearest future. Economics.
In principle, this is the space friendly towards residents and guests, where we feel comfortably in any environment. And that's an important thing, because we spend a lot of resources, we waste a lot of resources, we waste a lot of space that is created. Kira and me have walked through this Congress Center, and we have found that there are a lot of spaces here which are not needed, which nobody will use, and this is also part of. This is also one of the objectives, to be more rational in setting up infrastructure. That has to do with ergonomics. We can plan with a small redundancy, or we can plan with a huge redundancy, and there will be no one in the space. It will be too huge. And this is where we pass over to item 4, which is economics in terms of a language more clear, which is a clear language. It's sustainability in management and maintenance. Each cubic meter needs to be managed, maintained, needs to be operated, and you need to pay for energy spent on it. And that's also where we urge the professionals to be more efficient in using resources, and in creating square meters for their properties, because that's all about money. And emotions are something like an engine. There is a case of Bilbao, which nobody knew before they built a museum, and it changed the polarity of the city dramatically, and it emerged on the maps in terms of media. The tourists started coming in, and that's only because of one museum, and that's just one example. A museum, new jobs created, comfortable environment where humans feel good, environment in terms of ecology and so on. A few cases, a few projects that we have implemented include Hypercube in Skolkovo. That's the first building, which is a prototype of the architecture of the future with a very advanced engineering. It was certified to LID, to the American standard. We have argued with Rob Vossen, who authored this standard, whether certification is needed at all. And do we need to use social matters as criteria for certification? For example, the LED screen that uses up a lot of energy, he would not want to use that as part of the standard for the certification. But when we started discussing that this screen can perform a social function, and it can attract flows of people, he's thought about adjusting the certification just like Brim is doing. This includes a certificate. This adds up your score if you meet the demand, the social demand in implementing your project. LEED is only about energy efficiency. It's quite a rough assessment. The geothermal wells also were also assessed. There were 10 of them here, 60 meters deep, and they provide ready water with stable temperature. And in the summer they work for cooling, and in the winter they work for heating the building. We included emotions as an E number 5, which is a matrix here in this building, which is called the matrix, and we researched a higher level functionality by introducing an exhibition gallery, a transformer room, a transformer space for different events. That's how we combined an office building with its social function. A very simple country house with a complex design, which is a private property, and where we worked with passive properties with passive energy consumption, where we increased the thickness of the wall and minimized energy consumption. And it was then that my Swedish colleagues informed me that the price of the building, the cost of the building, is calculated based on the whole life cycle of the building, that is about 30 to 100 years. And if we paint the pie diagram, then 1/7 is the construction cost, and the rest is the maintenance cost. The cheaper you build, the more you pay later. Everybody wants to build cheap. This is very natural. When you see the figures, you get scared and you choose the lower figure immediately. But you really need to think twice before deciding, because because you will pay more in the process of maintenance, in the process of the building's life, and this figure will be much higher than the figure that you have agreed to, and that's actually the advice from developers. and that's advice to developers who will be maintaining buildings. You may not cut costs on energy efficiency. This property is more about emotions, about programming the area, the space. That's a triumph arch built in Nikola Lenivets village. That's part of tourist traffic direction objects, properties. Yeltsin Center in Ekaterinburg is an example of social programming where you understand the functionality of the property, which will be a museum, an archive, and a library, and it becomes an engine, a hub for the whole area, for the whole neighborhood, and it offers a lot of many other things, including art galleries and events for school kids, and events for accessible events for people with disabilities, lectures, conferences, city services, and others. This seems to be an important part of today's development, which we need to integrate in the new standard standard level certification standard, which will help build properties of a totally different quality and that will move economy forward. This is where I'd like to give the floor to Kira, and she will speak about programming. And I will start by an introductory word. A developer with a very good approach, whom I met in Ekaterinburg quite long ago when we were building Yeltsin Center, showed me the property that was not built, that was not completed yet, the Malevich residential buildings. We started talking about the front sides, the facades of the buildings, and he started talking to me about something totally different that I really took interest in. And he said that it's not the facade that's the most important, but it's the community that we are creating. And he explained how they're doing that. And I'd like to ask Kira whether it's important for a developer, for you personally today, how the user will be living in the building, how they will engage with other users, and I'd like to know how this is implemented in Malevich and maybe other projects as well. Good afternoon, and hope you can hear me well. Thank you. For us, it was very important to learn from the wonderful case of Malevich. In 2014, when we completed the first building, we created the opportunity for ourselves to track and monitor the life of the building after it was completed. And we were pleasantly surprised, and we admired how people started engaging with each other. For example, there's an announcement board that was called Hi Neighbor, where you could write your name and what you do and your phone number. And this is indeed very, very good, where you can share a service or do shared purchasing. And the residents were also active in creating a kids club in the second floor. They had a web chat in the messenger, and we could see that the house was living its active life. When we were creating the environment, we knew that it would have a positive impact on the atmosphere within the buildings, but we did not expect this level of activity, this level of engagement. And from what I know, Gennady Chernych told me that one of the people who bought an apartment in this residential building, and who also works in this development in Gennadi's development company, Princip, was at the head of this community, and he started structuring this community. In particular, they introduced rules for maintenance of the buildings. They would kind of oppose the people who would try to enter in a car, because part of this park is car-free. And I thought that was a great example, because there are very few developers who think about it at all. Even for those who own dogs and other domestic animals, they had a special kind of bath for washing their paws, and also a dispenser for cleaning after your animals. We understand perfectly well that the principle of any property is its end user, meaning the resident, and what's important for them is comfort, but we also need to create additional functions, other conditions. This will also create value for them, for this resident.
In the next project, you have applied this experience as a part of project design. Yes, that's true. We decided that we will support the activities and this interaction between the residents. And this story gave us the idea that sharing the public spaces is the ideal model for the future. Just consumption only in the service sphere, but in the housing and commercial property. So, and we decided to bring more public, live public activity, so, and just create more spaces for communication, for business. Why I say we? Because just abroad, this is a bit different format. So, and we call clearing like just big spaces where people gather together and share their experience, and there it is like an incubator of the creative people. So we'd like to bring that idea to our project. So on the first floor there are some studios, some halls for meetings, lecture halls for up to 50 persons. Here you can come to work with your laptop, co-working, and you can just meet new people and exchange your professional experience, and so on and so forth. So this is very comfortable to do if you live with these people in one house. This is the place where you can work and have a rest at the same time. So, and can developer give the offices or places which can be rented and bring the money? But this is all economy of the project. For such a housing format as Stadling, with several flats, with block of flats, when the just number of flats exceeding the critical figure, and it allows to create the developed system of halls, entrance halls, and it will not give extra expenses. For such Tatlin project, we decided to use the model, which is considered to be an experimental one, and we are going to see how it will work, how successful it will be, and then we can analyze the results. And after exploiting the first Statling building, we can give some just conclusions, but now we can understand that this is a very popular place. And if we look at Yeltsin Center, when we only started this project, we doubted if there should be some places for some public functions, public places, or maybe these places should be rented. And then we could understand the generation of the flows could provide another functions. And give a possibility to rent it to more participants. And that's very important that modern developers can think about that. And the first floors are becoming public places. Thank you very much to Kira. And now a word flows to Juliet, and she's going to talk about industrialization. As I mentioned at the very beginning, we are moving to huge numbers and increasing number of the population, and that means that we have to think about how we can find or build enough square meters for the people. And we should say that all these plans and concepts were developed in the 20th century in constructivists. If we look back into the history, we could find some answers to these questions concerning the construction and the usage of the spaces, programming, and just living, sharing these living areas, and sharing it's just functional usage. And I'd like to show you a film, a short film. And if we talk about Juliet, she's the head of the company. Maybe you have seen in the internet a video how to build a hotel with interior for 2 weeks. With all the equipment, kitchen, bathrooms, with all the switches and so on. And I think that, of course, this is our future. And module construction, module type of construction is our future. And anyway, China can show us unbelievable growth of such project implementations. However, such projects were in Europe in the 50s and 60s years, and it was associated with the military industrialization and the necessity to develop the just project of infrastructures in the shortest period of time. But this is quite another level. This is a new quality level when the interior is a part of the industrial process and everything is done at the production factory, including all the panels and doors which are placed according to the sketches. And of course, this is a new type of architecture and another approach. And of course, this is a challenge to specialists, because so this demonstrates that we will not need the specialist service in the nearest future. So the process will be automated at a very high level. And this is a typical process, and architecture becomes only its function. And this is the 5th E, which is an extra one. Here we could see a technical decision. Could we go back to the presentation? Thank you very much. And the word flows to Juliet. And I'd like to ask her how she can see the architecture of the development in the nearest future and why they focus on the speed of construction.
Actually, I don't know if I heard wrong, or because 16-story New Ark Hotel actually was built in 1 week, means 6 days.
Значит, я ошибся, я сказал, что 2 недели.
That was my mistake. I said it was 2 weeks.
That's true. So that's why I said, well, 1 week. Okay, we built that. And so actually that was our first generation. 9 years ago, we built this and we showed the world. It was the carbon steel. But now we have the latest one. It's the 6th generation.
Наших зданий, и мы используем нержавеющую сталь, то есть Борис показал вам новое поколение. Мы построили множество других зданий, мы построили 59 зданий уже, и все с нашей технологией, вот с помощью вот этого материала. Я хочу подчеркнуть вот эту новейшую технологию, потому что она соответствует тому, что упомянул Борис, про вот эти вот 5 Это с помощью, вот эта нержавеющая сталь живет вечно, она не приходит в негодность. Французы создали в 1867 году.
That was 152 years ago. Ever since then, all the buildings are using concrete. So we know technologies actually develops very fast. But for this industry, construction is the industry, not much change. People still stay in slash and burn period. Farmers, they work in the countryside. If the construction site needs them to work, they become construction workers. So actually, quality is not so reliable. So that makes a difference for us because we have everything done in the workshop, in the factory. And also our energy efficiency. I noticed Boris was talking about passive housing, right, in Germany. Yes, for us, we also have adopted that. For our buildings, energy consumption is 1/5 of the conventional one.
В размере
For example,
1/5
if
части
this
традиционных
building
зданий.
in front of us, this 30-story hotel we built in 15 days, 8 years ago. Energy consumption is 70 kilowatt-hour per square meter per year. Similar buildings would be 350 kilowatt-hour. So. And also air quality.
Что касается качества воздуха, то оно в 100 раз лучше, чем снаружи. Я проверила воздух.
Very good. But indoor, still lack of oxygen. Your fresh air is not enough. So that's why if you stay in this room for a long time, each of you would have red face, lacking of oxygen. Okay? So for our buildings, we have 100% fresh air filtered all the time. Why? We have a heat recovery devices there, so that can recover the energy by 80%. So that's why we save money, And the air we breathe is like the hospital ICU air. So this is very good for the human health, And also, according to our building, we have the smart, we say intelligent building. We have 5 principles, okay? And intelligent planning. You see, just now I listened to the Minister of Construction, and actually everybody was talking about city planning, how to plan the future cities. And actually that's what we have been concerned. In China, every 1% of increase for the urbanization, that means 10 million people would come to the city. Housing would be a big issue. So if people still construct concrete buildings, and after 70 years or 100 years, it's all construction waste. Yeah, this is the future. Actually, this one we call Green Tree Tower. It's the one we built with this technology. This latest one, 16-story, we built in 6 days, 3 stories per day. Okay, so it's at the bottom is 150 square meter, on the top 1,100 square meter. It looks like a tree, and also energy efficiency super high. We have thermal insulation for the wall. We have triple pane windows. We have fresh air inside all the time, quality air, you know. And so that's why just now I said city planning, intelligent planning, this is very important. If the urban planning was wrong, it takes 300 years to redo, you know. So that's why it's a mistake that will take generations to change. So that's why the decision makers need to have the right planning, intelligent planning, and intelligent material. So that this material, stainless steel, and then last 10,000 years, you know. So that's why if you build a house, you can pass to your children, your grandchildren, and grandchildren, right? Generation legacy. In China, our parents spend our life saving to buy apartment for our children for their marriage. But after 70 years or 100 years, it's all construction waste, you know. So that's why, yeah, this is a good solution, you know. And right materials, intelligent construction. That means we do it 100% in the workshop. So in this way, worker-friendly environment. On the construction site, it's like playing Legos. The reason we can achieve 3 stories per day is because we do all the workshop, the work in the workshop, okay? So that's why, yeah, it's intelligent construction, and we save labor, okay? And also intelligent efficiency. Just now I mentioned about the energy consumption, only 1/5. How can we achieve that? We have so many measures inside. Like the air conditioning, we use waste heat air conditioning. That means it's waste from power generation and no money for operating cost. CO2 emission, 0. We developed this in 1999. It's our own product. The US Department of Energy, the Americans bought our first one in the world, okay? So we use this kind of equipment, save money for people. Thermal insulation for the wall, windows, we use 3 layers or 4 layers, and even the elevator, the lift, is auto power generated lift. That means if it's empty, goes up, it generates power. Full capacity with people descending, it generates power. Initial investment for this kind of lift, it's 10% more. Within 1 year, you got the payback. So we have all these kind of measures. So that's why we can achieve smart efficiency, okay? And then the last one, the last but not the least, okay, it's smart comfort. You enjoy the comfort, you know, and also quality air, healthy, happiness index higher. So that's why we are designing our buildings with this kind of concept. We say 5 plus times 3 principle. It's all smart, smart, okay? So this kind of slab, not only for the buildings, but also for highway, car, ship, aircraft, because super light and super strong. So that's why it, creates everlasting civilization. So I agree with Boris, in his design for all these kind of buildings should have the 5E. And we are also trying to do this in this aspect. Thank you.
Спасибо, Джульет. Вообще, я еще немножко прорекламирую Ельцин-центр. Вот Джульет очень важную сказала вещь. Качество комфорта, то, что она назвала смарт-комфорт. Вот я, когда приезжаю в Екатеринбург, я останавливаюсь.
When I came to Ekaterinburg, I just stay in Yeltsin Center residence. There are only few rooms, but there we prepared water supply with the special filters for water preparing. There are the nearest hotels, And when you fill the bath with the water, you can see the yellow color, but in Yeltsin Center residence, you can see the blue color water, and this is a sign of pure water. And there are quite serious engineering system for air filtration, which are above Soviet standards. So the flow is not 20 square meters, but 30 square meters. There is enough air to breathe effectively. All modern buildings are constructed without windows opening, just to control the energy efficiency, because if you open all the windows, there will be just climate changing effect, and there will be unfiltered air will get inside the room. And our users or consumers always ask, is it possible to make a small window in the skyscraper? And of course, it's not possible because there is a question or dilemma between energy efficiency and just quite good standard conditions. So, and concerning the projects which Juliet told us about, no one window can be opened, but everything is controlled by the modern engineering system. And this is the principle of house passiveness. It's very important to find out information about some details, but I'd like to go to our questions. So if you have any questions, don't hesitate to ask, and we are going to answer. Thank you very much. У меня
company recently organized an international architectural competition called Sky City Challenge, and there you invited both professionals and students to create some innovative ideas for new housing units, some universal models. So, and then you presented the entries at the Asia Pacific Forum for the Green Low Carbon Development. So I wonder which solutions did you find out while discussing this issue at the forum? So what are your findings?
No, thank you very much. Yes, what you talked is right. We call for international competition, and actually we displayed those designs at the entrance for the low carbon Asia Pacific Low Carbon Forum on Sustainable Development, which was opened by Ban Ki-moon, the UN Secretary, the 8th UN Secretary General. Okay, yeah, actually because the competition was organized by another team, all foreigners, not Chinese, from Europe and US. So that's why myself, I'm not so involved. I know they give young people more opportunities to display their talents. I know, and also I saw some marvelous proposals, So actually, we ask more people to involve, to take part in. We also have very good reward program for that. Yeah.
Oh, and did you present your B-core slabs material at the forum? So did it prove energy efficient?
Oh, definitely. We have, like this green tree tower, the one presented here, the energy consumption per square meter per year, it's 100 kilowatt hour. Similar one would be 500 kilowatt hour. We have all the datas, so figures talk and money talks, So that's why. And also low carbon forum, it was held by the, Chinese government and Asia Development, and they selected our campus, our green campus, to be the permanent venue. Each year, they would have that forum on our campus. So on October 16th to 18th, that was the forum you mentioned, and that was the one 8th UN Secretary General Ban Ki-moon came and launched that. Yeah. Thank you.
Здравствуйте. Вопрос по управлению жилыми комплексами, которые
management of their houses. So how the management companies should be close to the construction company, and how well our legislation, which says that there should be the competition between choosing the management companies, are fair. So this is the question to your neighbor. So so they don't need to do that. We don't have a compulsory legislation that the management company don't need to have any connection with the construction company. It happens due to the fact that, like in our case, we were not happy about the work of the management company, which came after the just exploitation of the object. We were not happy about how they take care of the surrounding territory. We wanted our house to be as beautiful as it was initially after being constructed, and it forced us to make our own management company. Good afternoon. My name is Agafonov Natalia, so the Department Grant Project. My question is to three speakers. How well and at what stages do you use BIM technologies in your work? Juliet, do you use
BIM?
Yes, we do. BIM, yeah, we do, yes.
Кира?
Да, мы используем и все больше и больше. Пока
now at the stage of design, but then we start to use these BIM models at the construction stage. Yes, I have used BIM since the time when it only appeared since 2005. So I use only BIM technologies. Now this is a modern topic, and we are a bit tired of using BIM, and we'd like a new thing, but now everyone starts to use it. I'd like to ask one more question to Juliet. So if you use BIM technologies in the construction, can you give some details about using BIM technologies in construction?
Yeah, I will. I need to excuse myself because I'm not the architect, you know. I'm not the designer. Myself, I'm the founder for the company's international business. So I'm mainly for sales and marketing and management. So that's why the details, I don't know our team, what they are doing. But actually for this kind of building with this B core, you know, we have our standardized design, you know, with the beam, and then we have worked out like a 16 floor, 24 floor, 32 floor, 64 floor, and 96 floor, and 100, you know, that kind of, you know. We have all the standard one because we want to make it an industrial product so that we can sell it at lower cost. If each one is, you know, tailor-made, and then the price would be very high. So that's why the details for the beam, our designing department would have more say. Myself, I'm not involved for the design, but I know they are using that.
Я могу ответить за Джульет, да. Потому что, конечно, сегодня все компании, инженеры, те, кто делают абсолютно все...
people who develop the Windows and some other technologies. So they use BIM technologies. This is a standard of WHO, and in 2005 all the constructions were done in BIM. So, and then your model can be connected to the city model, urban model, and they can evaluate the loads. And if your model, according to the loads, didn't correspond to the city loads, then you had to start the design from the very beginning to follow the standard. So in China in 2005, they didn't use BIM technologies, but China can develop all modern technologies at a fast rate. And we remember that just according to different stories, Siemens and other technologies, they use all progressive technologies, including BIM. My question is to Boris concerning 5E. So we suggest that every E is important, or we can just not use some E. Yes, of course, architecture is a thing when everything is important because it is designed for a long time and every E is important. Really, we have 8E, but we decided to limit and use the rough just tuning. For example, we have E as ethics, ethical aspect, which is important for the development. Also E like exploitation, how this building was processed or was exploited. So this is a long-term process which should be considered as a complex one at a state level, changing some legislations aspects. So with changing something in the urban planning code. This is the same situation as with the roads. So just in the past, the clever countries built the roads and not clever ones didn't do that. And those who did that, who built the roads, they started to become richer because that was an important thing. And in the Rome, so they started to build roads from stones. It was since the Rome time. And the same concerning the standards. Because only standards can give us cumulative effect. So, and answering the question, can we just delete one E? Of course you can, but you can lose about 80% of effectiveness. My question is to Kira. You told that Malevich is an example. You have some co-working. No, not in Malevich, in Tatlin. How will the people access be organized? Is it a paid service or free service? If it is a paid, who is going to pay for that? Almost all areas are public areas with free access, and some master work classes, so some lecture halls are commercial spaces which you can rent for an hour or can agree about any other time, or you can use them if you pay the money. So is anything free nowadays? Can you show me where we can find it? Any more questions? Good afternoon. My question is to Boris. I'm a person who is intolerant to ecology and architecture. And of course, in Russia, everyone is ready to talk about ecology. But in the development, this is a very difficult topic, especially in the regions. But I'd like to ask about your opinion. Will anything be changed in the nearest future? And how can we explain the customer to this issue? We can show the economical aspects, or maybe there are some other ways how to let them think about that. You talk about ecology during the construction time or exploitation processing or life cycle during the exploitation. So then we talk about ecology. For example, social ecology is also a part of ecology, how this or that object is involved in the social flows, integrated into the social flows and their attitudes to this fact. One taxi driver told about Yeltsin Center as a very nice center, but another taxi driver had a very negative opinion about that. And he said to me that his attitude was a political one concerning the exploitation ecology. This aspect is regulated only at a legislation level, and personal responsibility of each developer, how much he wants to make a competitive project. That's an important to for long-living company, a long-lasting company on the market, just to survive and well behave are the same actions with the same potential. So only people who make the right actions could survive in the market. Those developers who will make extra negative effect from or those who can make ecologically friendly effect with clean walls, just right society, then the population and the city will benefit, and the developer will benefit because he will get more money, because more and more people would like to have the right attitude to their place of living. So this is not the place where he can get to at a very late time, but this is the place where he can
of population, of the world's population. There are more and more humans on our planet. There is less and less space, and we need to somehow find common grounds, and for that we need common rules, and these become natural things because people tend to mirror what they see. If they see rude behavior, they will find it difficult to respond to that rude behavior. As the same concerns environment. When we were building the cube, Rob Watson was looking at the construction, and we taught the builders how to dig the construction pit in order to prevent the liquid from spilling out, or to prevent the a small lake from being destroyed, because there was it turned into a source of dirt, of mud. And when you start working on these small things, you can see that you are working in a very in a kind of box. And if you start throwing out waste, you are throwing the waste kind of at your own feet. And it seems that we need to educate people about that, and we need to educate everybody, and then things will change for the better. I've traveled a lot to Ekaterinburg since 2008, and the city has changed dramatically, and this seems to have to do with information development. Instagram and Facebook seem to work better than all federal media, all national mass media, which only provide and publish terrible, threatening news. And Instagram and Facebook, if we look at the percentage, there is, of course, a huge percentage of news about terrible things, but there are also a lot of emotional news, emotional pieces of news that create a kind of group for imitation, and this imitation creates cumulative effect for the communities. Good afternoon. My question is to Boris. To continue the previous question, I have a similar question about energy efficiency. What do you think? How many years will pass before we will arrive at the situation where these parameters are integrated in laws, and about this, how much heat can be lost, which one would be appropriate, and lacking this standard, how do we motivate, how do we provide incentives to developers to focus on this, at least in low-rise construction, at least in small projects? And the last question is, how many companies do we have in the country which can implement a project like Cube? I will start with the last one. Since 2010, we have had a lot of companies emerge that work with efficiency as in such a way, in any way, to an extent. There is a term that has recently been used by all large institutions, which is sustainability, and in Russian, it was translated as kind of stability, but that's not the optimum, the best translation, because the stability can be different. If we speak about sustainable growth of economy, it can have to do, if we talk about stable growth of economy, it can have to do with aggressive consumption. This means that economy has to grow everywhere, which I doubt is necessary. This means we need to consume more and more, we need to buy more and more products, we need to dispose of more waste each year, we need to buy new furniture and new cars and new clothes every year. And this may be more about the Russian translation of sustainability. This is a term that has to do with with something that was imposed by the Western culture, by the capitalist idea, the idea of aggressive consumption of everything that we can consume. If we count how much an average American uses in terms of gas, they consume 6 times more energy and fuels annually than, say, a European, someone from a European country, and maybe 12 times more, 8 to 12 times more than someone living in maybe in the area between St. Petersburg and Vladivostok. Given that the American economy is strong and continuously growing, but this says that stability or sustainability has a different meaning for each country. So the right translation would be sufficient, what is needed and what's sufficient. This term is mathematical or physical, and it means that you do not need to consume more than you need. If you have a car and if you have a coat, you have to live with this current this code until the expiration of the life cycle of both products, and you do not need a new car or a new code. And the same concerns homes or any types of buildings. We seem to build more than we need, and this is an answer to the first question, and concerning energy efficiency. It has to do with the quantitative parameters of something else rather than the amount of consumed energy, but rather in terms of energy efficiency of the building, in terms of the building fitting its purpose. We have been designing a country house near Moscow, and we have this client who wants a house of 350 square meters, and I tell him, you do not need 350. The maximum you need is 200. He says, oh, 200 is too little for me. I have a lot of jackets to place there. I have a lot of pants to place there. I have cars. And I say, you don't need that. We will build a better bedroom. You do not need a big bedroom. You need a small bedroom because this is where you sleep. This is a room, but you will have a big living room. But the bedroom will be smaller, and that's how he got used to this idea, and he realized that he did not need a 350 square meter house, and we are planning 200 square meters where he will have enough space for everything. Things depend on, so it depends on many things. Today we can even build a house without connecting to any electricity sources. If a country house have a geothermal well, this is optimum. Solar batteries are wonderful. I will not say the exact figures. I need to talk with engineers, but I can just leave my email, and I will then get back to you with the answer. And the question, everything boils down to what you do in the home. The functions of a house or a building affect the energy consumption. How long you spend in the house, which seasons you spend in the house. We can calculate for the annual figure, and it will still be different in Moscow and in Siberia and in Chukotka. The figures will also be different, and we need a kind of index that will show the common parameter of class, of category. They have classes in Germany, they have classes in other countries. We do not have classes in Russia, and it's an objective to develop this category system, this classification. When Dmitry Medvedev was president, we had a lot of programs for shifting to energy efficient technologies, and it would be interesting to ask him about the outcomes of these programs, how they were implemented, because this is a great part of the country's economy. But I know that a lot has been done. I know that Moscow is adopting very actively energy efficiency solutions, energy saving solutions in residential buildings and office buildings and new properties being built. This has a lot to do with the cost of energy that is provided to the property, and engineers adjust the costs based on this data. We are following the model that a lot of countries have followed. If we look at the models that Europe used 50 years ago, or that the United States used 30 years ago, we'll see the same steps that we are making today. the same will be happening. The non-renewable sources will be more and more expensive. The maintenance will be more and more expensive, and everybody will be using passive housing.
My question is to Juliet. As I can understand, so these houses are made of the iron and steel. So we are making and we are using such materials. We don't use these materials due to complex construction regulations, so this is a bit problematic to make such buildings constructions from these materials. Did you face with such problems with your authorities concerning the construction regulations and some fire rules? Fire protection rules? Maybe you don't have so many rules. Maybe you could make an agreement with the authorities. How much time did it take, and was it a problem for you?
Actually, yes. We are using this new material for the buildings. That's why even the whole country doesn't have this kind of standard. Actually, for this kind of stainless steel, you see the Americans use them to make honeycomb, for the spacecraft, because it's so costly. So that's why they cannot use so for the whole aircraft. They cannot. Only the space capsule, they use the honeycomb made of stainless steel. And our chairman came to find this. It's because he was buying his own business jet, 1996, in the Americans, So in the aircraft factory, he saw this, and he was trying to take care of that piece, and he realized it was so light and so good. So he questioned how much it cost. Then they told him 40 or 30,000 US dollars per square meter. So then my chairman had a dream to make this kind of building materials. Everybody could afford it, So that's why he developed this. And it's true. In our country, we don't have any codes or standard for this, but the country already asked us to write our own companies, and then we ask experts to evaluate, to do all this kind of evaluation. So that's why for this building, we already passed. We got the permit. So that's why after certain levels of this kind of construction approved by experts from China, and then our standard, our enterprise standards, would become the national standard. It takes time, it's true. But for firefighting and all those things, we conform to the national standard. And also, itself, actually, it lasts so long. And also, thermal insulation, this kind of energy efficiency and all those, we have all the advantages, Yeah. And I want to share a little bit. Boris just now talked about, answer that lady's question, and then I have, I can't agree with Boris more, Really, he's so right, Nowadays, people try to buy big cars, buy big houses, they change, they consume more, they consume more than they can earn, In our company, actually, we are promoting a low carbon life. So that's why we don't use car. We have low carbon bonus for that. And we encourage people not to buy big houses, because the earth, the resources are limited. If we over-consume, then how about our next generation? So that's why our company is devoted to education, for this climate change education, from kindergarten, from elementary school, high school, because adults over 18 years old, it's difficult to change them, So that's why we have already a green foundation to educate kids from kindergarten and elementary school, high school, to teach them how to, don't buy more than you need, So just enough to meet your requirements. Don't enjoy that kind of luxury. You can save more money for organic food. This is good for your health, right? And also international, this kind of flight. If every year you get one or twice, your carbon, the footprint, the quotas for the carbon already gone. And actually, keto protocols, we signed more than 31 years, So in that keto protocol, people promise to cut half of the carbons based upon 1990, 210 tons, per capita. But actually nowadays, our carbon is 500 tons. We didn't lower to 100 tons, but we increased to 500. So our generation, future generation, they have no place to live, So that's why this is very urgent. So our company is promoting this kind of, education. We think there are 4 aspects that could educate, Actually, it's the national policy. The government should have policy. The Ministry of Education should change their textbooks to educate people how to, to be low carbon. So this is one. And another, corporate or enterprises, they should develop technology or products that really can cut CO2 emissions, like to be energy efficient one, good design for the buildings and those, This is the second level. The third level is urban planning. So just now I mentioned, it takes 300 years to rechange an urban planning. So that's why if you have the right urban planning, it's a walk to work concept. Instead of being a commuter, you spend 2 hours on the way. Actually, it's 10 minutes or 5 minutes to walk to your working place. More greenery, more activities, you would feel happy. Actually, more quality life, more quality hours with your family. So that's why urban planning is very important. The 4th level is the awareness of this. Everybody knows, based upon this 1, 2, 3. So that's why the 4th level is the awareness of this, protecting the earth. So that's what we have been doing. And that's why in the morning, I share the 90 minutes for our company's low carbon life and disruptive products. Okay, I do hope everybody would really educate your kids to be low carbon, Thank you.
Спасибо, Джульет, спасибо, Кира, спасибо, что пришли.
Thank you.
До свидания.